We are.
Perfect.
Okay, we should be live. Hello, hello, hello. Welcome to the stream, everybody. Oh.
Hello.
Let's see here. New setup for me, but you've streamed with this one before a little bit, right?
Yeah, a little bit.
Yeah. Well, this is
Matt, I work here at Biogenomics. This is our lab. Trying to figure out, fix some issues with the 6400 tonight that we've been having, and just get it into better shape. So,
yeah. So what are we gonna start with?
Well, we just turned it on, and
Yeah, that's pretty funny.
V7 is currently not looking amazing. It's off. V7 is off. Our emission lamp is on. So that's probably the first thing we have to look
That's
at.
weird. I haven't seen this really before.
Yeah, it's the first time I've seen this happen ever myself. So
Yeah, so we have the valve is off for some reason, and I'm sorry, I'm just making this display brighter so I can like see it. But I keep on managing to do weird things to it. And then I think we have, I can hear the stream somewhere too.
oh, that might be my phone.
Okay, I got the thing selected. Yes, I'm okay with it. No longer being Energy Star efficient, that's fine. Okay, so yeah, so you want to point the camera back at V7?
Yeah.
So V7 here, if you've worked on 6400s or 840s or kind of JEOL SCMs of this era, V7's a pretty important valve that you think a lot about because it is the valve that is the column isolation valve. It's right in the middle of the column. If it's closed, you can't really get a beam. Usually V7 opens and then the lamp behind the emission current meter turns on. And so when that lamp is on, that means that the interlocks are met and you can turn the beam on. So we're in a kind of a weird condition here. I have theories. You had all these cables here.
Yes.
Did anything get unplugged?
That's
So,
a good question. I
there
could
are-
have bumped it while I was cleaning.
There are things that get integrated into the vacuum board that interlock V7.
Okay.
And
I think those are mostly stage controller cables. We're talking about this bundle of cables right here. It was inside the scope, but I was cleaning it under there a little bit this week, and I pulled them out.
We could also maybe have something going on with a load lock, maybe. Trying to think if that could be the case. I don't know about load lock causing a V7 interlock to be weird. Oh, that is very tight. Okay. So I have not opened this door in your microscope before. So.
Yeah, I haven't either.
Oh, okay, interesting.
I haven't had a reason to yet.
You have an interesting style of 6400ing.
The autofocus is terrible. I'm switching to manual.
What's going on here? Okay, it's just caught on one of the solenoids.
Ah.
There we go. Okay, nothing's immediately jumping out to me as being terribly weird or modified or having some type of...
When I was cleaning, could I have maybe messed up one of the jumpers on the solenoid board down there?
Down there?
Yeah.
I mean, it's possible. I don't think that would result in us losing V7 illumination like we have. Let's so we could have a set point issue. I think it's separate set points for V7 and for vacuum gauge. Okay, first what we'll do first. First we're gonna go to manual.
Okay.
So what manual mode is gonna let us do is oh, I gotta move the chat window. Also, hello chat. Welcome to the stream, Monochroma. Meow no chroma. Great to have you here.
Hello.
They have an 840, a 6400 control console, and a 6300F.
Oh wow.
So they
Loaded.
6,840. Okay, so we're gonna go RP on, DP on. I'm just gonna match the current state, V2 on, and we'll just stick with those. No, we'll go V1A, V1B. Okay, so we got RP, DP, V1A, V1B, V2. RP, DP, V1A, V1B, V2. Okay, let's go to manual. There should be no state change, basically.
Beautiful.
We don't have V1C installed because we don't have a turbo pump.
And the I noticed when we switched to manual, the V7 valve didn't click, so it must.
Well, I did. Yeah, that's true. So it must have actually been closed, right? So if I
Yeah.
open V7,
Nothing. How did the interlock trip then?
because the interlock is based on pressure, but V7 is also based on pressure. So if I'm
Okay.
not able to like manually actuate V7,
Yeah, it must be disconnected or something. Should we trace it down to that solenoid
yeah.
board?
Do you want to get your schematics book out? I want to look at the drive circuit for V7.
Yeah, let me go grab it. It's in the other room. I'll be right back.
So we got a whole bundle of cables down here. These were all just like kind of in there, and these have been pulled out from in there. Hello, Maria. Welcome to the stream. Good to see you. We got a Maria in the chat.
Yay! Circuit diagrams.
Love some circuit diagrams.
Which are we looking? This board.
Yeah, but okay. So let's show chat.
Yeah. Okay. Here, I'll bring the macro around here.
So there's a cable here, very suspiciously labeled VAC.
That definitely wasn't plugged into anything. I'm pretty sure it was just laying.
PCD. So this is PCD is probe current detector. So that's interesting. BE8. That's like a groundy. Oh, BE8. Why do I always forget BE8?
That goes on. Oh shoot! I feel like I remember somewhere in my mind where that goes.
I feel like BE8's a stage thing. What do we got here? Y. Okay, so we do just have some cables that are unplugged at the moment. That's always fun.
Yeah, I think most of those are for the stage controller.
Yeah. So we got V7. Following the So that goes into like the normal bundle for V7, seemingly, right?
Yeah.
Light, vac. So this wasn't plugged into this?
No, I didn't unplug anything.
Okay. X. Yeah, I guess it's marked X.
And I pretty carefully lifted that bundle out too.
Yeah, I could be chasing a red herring right now, but this does just seem like the type of thing that's kind of likely. Okay, what do we got here? Okay, that's another cable that goes to nothing. Okay, schematics time, I think.
All right.
So yeah, no V7. That is interesting.
Oh shit! I just unplugged my camera.
It'll be back in a second. This is gonna be fun. I can already tell. Okay, so V7 is here on CN10. It is connected. So we have, it looks, what's going on? So we have BN5 OES. So the BN5 jumper, I guess, so that's like all of our grounds being tied together.
Okay.
So then our drive signal is BKS here. So BKS back through this. So BKS is pin 8, CN9. So CN9, pin 8, so TR4, yep, V7, okay. So D23s are LED, because the LEDs are actually like just basically right off the transistor, right?
Okay.
And it, so if you look here, so we have these, 1H, 1F, 1E. These are, I don't remember exactly what 74 series chip is that?
Oh shoot, oh wait, no, never mind. It's there. Just a little dark.
Yeah.
Here, I'll try to boost the.
Do you want to go kind of more top down?
Yeah.
Okay, so and then can we do yeah, let's do that. There we go. Okay, cool. So the purple pointer zip tie. Okay, so V7's right here, right? So TR this one's V7. So TR4 drives V7. D23 is the diode on V7. So the diode just lights up when TR4 is energized, right? So that's the what we see on the front panel there is that diode.
Okay.
So TR4, and then this is a pull down, I believe. No, that's a pull up to 5 volts actually. R6 there. So that's a 5 volt rail. That's a pull up. And then that's a inverter. And nope, I'm one over. Okay, there we go. Inverter buffer basically, and come down to 1H. So 1H, 3Y, and 1E. Those are the reference designators. So it's rows and columns on this board. So number letters, like what is how you find the chip on the board.
Okay.
So I'm looking over here. So 1H, 1F, 1E. So I see. So this is a 74 LS 157. So basically, what this is doing is these are the manual automatic switches.
Okay.
So we have 4B and 4A right there. So 4B is the automatic input from whatever like the rest of the logic is determining the sequence to be.
Okay.
And 4A is the V7 switch that we're using manually.
Okay.
So we're able to flip all these into auto manual for everything else. But for some reason, from here to that LED, we are like not getting control, and they're really shouldn't be a lot, like it's really not a lot going on here. You know, it's buffer inverter, pull up, diode, transistor, and then output LED. So it's like maybe somebody modified something, but there really just is not a lot happening here.
Yeah.
And it's for sure not open. Yeah.
And it was working fine for months.
Yeah.
Years even.
Years, yes.
Until this very evening.
It could be open. The reason I don't think it's open because
It's not shutting.
Yeah. Okay. So I'm going to manually actuate V7.
Okay.
So V7 has got 2 solenoids coming out of it.
Are you actuating it with like a jumper?
There's a push button on every one of the solenoids actually.
Oh, I didn't know that. Okay, let's get a video of that.
So you see we got our valves here, right?
Yes.
So you see that red button?
Yeah.
So that's a mechanical push button. That's not electronic.
Oh, okay, gotcha. Yeah, the light's not changing at all.
Because
the
it doesn't
valve's
know.
not clicking.
No, the valve is.
Oh, okay.
It's just slower.
Oh, okay.
I can hear it.
Yeah. So the valve works.
Yeah. And because I'm pressing it and it's actuating, we know it's not currently actuated.
Yeah.
So that is weird. Okay, let's just look at.
The only thing I'm concerned, like when I scrubbed some of this down a little bit, and I'm thinking maybe I just bumped one of the connectors there, or rotated it kind of out of place.
So, I want to say. I think it's this pair, this V7 right there.
Okay.
And then, because that's the BKS and then the brown ground. And then that goes just back into this bundle. But that wouldn't explain why we don't have an LED.
Oh, because the LED is like basically tied directly to the switch.
It's not. It's there's a couple of devices between the switch and the LED.
Sure.
But the
They're
LED
pretty close.
is very close. I found it, I think.
Is it one of these jumper wires?
Yeah, there's a broken jumper wire right there.
Oh, shit. I wonder if we just scuffed it this week. I don't know.
So if we look at our schematics again, it was 1E, 1F. Okay, so which one? Yeah, I bet it's this broken jumper. But we can figure this out for sure, because no guessing. I mean, you can. It's just you're gonna have a better time if you don't guess.
Yeah.
Just like find out. Okay, so V7's controlled by 1H. Okay, so 1H, right?
Okay, sure.
Numbers, letters. And then output 4Y, which is pin 12. So that notch on the bottom is pin 1. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So fourth one down. Maybe the fourth one down. I could be wrong about that. What actually is this jumper doing? I mean, this feels likely, right?
Are these factory jumpers? These come on here?
Yes.
Okay. So they basically just like made mistakes in the board design and had to fix it afterwards.
Yeah, it might not be this jumper actually. Sometimes it's just like they couldn't route it.
Oh, okay, I see.
It could not be this jumper too, because I'm looking at what this jumper is even on, and if I close this jumper, it just like bypasses capacitor C11. Is what it looks like. And that's not making a whole lot of sense to me. To just like that deleting that capacitor would explain why we don't have our the V7 here.
Yeah.
So this switch is actually, so the unused quote switch is actually wired into this push button here, which I'm not surprised by. So that is like kind of frequently used as a V7 lockout, because it's on some systems, it's especially Lab 6 systems, you want to be able to lock out V7 so that when you do a sample exchange, you don't you don't accidentally get like too much air up into V7.
Okay.
So that's a pretty common use for that switch. And we did press the button and it didn't do anything. So we'll press that again. We're in manual still. Nothing's happening. I am going to go ahead and take us out of manual.
Okay. Oh, V1C turned back on. We must.
Yeah,
oh,
because I don't care about V1C because V1C is only installed if you have a turbo pump.
Oh, I see.
Yeah, soldering job's not necessarily the greatest on that, but that should be fine. Okay, I think I do need to actually start just like tracing out our circuit here.
Yeah.
And there is this little ball of fuzz. Interesting ball of fuzz. So what's going through my mind right now is that was working, did some cleaning, did other things. Things have happened to this microscope, like physically, right?
Yeah.
So, you know, electrical failures are of course possible, yeah, but electrical failures are generally speaking, spontaneous failure of electrical device is generally speaking less likely than something physically changing.
Yeah. Especially when I was in there so much the other day.
Yeah, like cleaning happened, right? So it's like, okay, let me just, the stage wire should just have nothing to do with this valve. None of these connectors. I mean, these, well, like the vacuum gauges do indeed have things to do with this valve, but we're not suspect of.
Should we check the test points and see what they're at, or?
We can, but manual mode would not have cared what the test points
Oh,
were.
true. Yeah, never mind.
Okay, I'm gonna go get my multimeter,
Okay.
and we're gonna actually start probing some things.
That sounds like a good idea. Yeah, it's for sure not open. We tested it. I don't know when you asked that. Maybe you asked that before we manually tested it on stream.
So I'm currently assuming, and I'm stating what I'm currently assuming so that we can stop assuming and start measuring and start knowing.
Oh, God.
Thanks, I hate it. Do not like these desks.
No, they're not good.
I'm currently assuming that we have an active, like, that V7 is being commanded to be open by the automatic vacuum sequencing.
Sure, so we'll check that line and see if it's getting a signal.
Yes.
Okay.
What did Monochroma just say?
Oh, they just asked. It's for sure not open, but and then I said I assume you asked that before we tested it on stream, and they said yeah.
Okay, cool. So we're gonna be volts DC here. I'm gonna grab. Can you grab the wad of multimeter probes that's right there?
Yep.
Thank you.
Here you go.
Thank you. So we're gonna be doing a lot of just like, is thing high or low relative to ground, right? So because we're gonna be doing a lot of is thing high or low relative to ground, I'm gonna put a clip-on probe into my COM port on my multimeter here. I'm gonna clamp that to the ground test point there. So that's our ground. So now, when I poke, we'll get a voltage reading. So like, for example, what is it? I think it's bottom left, or the pin 1 is, if I recall correctly, pin 1 is our 5 volts supply. Yeah, okay, so pin 1's a 5 volt supply on these chips. So we got, our 5 volt supply is a little bit low. We're at 4.877. You want to show the multimeter screen? So that's our 5 volt supply. So that's like just marginally low. But like I really wouldn't expect like a low 5 volt supply to show up as like specifically only V6 having a problem right now.
Yeah, that's weird.
So here's another weird thing for you. You ready for this one? This switch right here, right?
Yeah.
Whatever's been modded in here, it's connected to R6 right there.
Okay.
And you want to know what's interesting about R6?
What's that?
R6 is the pull-up resistor for V7. So what happens if I change the state of this push button here? So if I change the state of this push button here, we go from like 0.7 down to
0.15.
0.1, yeah. So that's with the button closed, that's with the button open. So with the button open, we are at a higher voltage. So this button appears to be configured to kind of pull that line down. So that's very interesting. Okay, so a little bit of, and then, this wire also comes down to a diode resistor thing installed on R48. Okay, so we got something going on with R48 right here. Okay, so what chip is that? Okay, what is that actually like doing? Where is that even wired to? Okay, we're gonna have to go to the other side. One of those appears to be, what is that? 5 volts, I think, probably. Okay, so yeah, one. So the bottom side here, bottom side of R48 is on 5 volts. The other side of R48 is at ground. There's a trace. The trace comes over to relay 1. Okay, what does R48 do? Okay. Somebody's been here before. Connect airlock to V7 column ISO valve, question mark. S block. Okay, that is yeah, that's, okay, I see. Yeah, why is V7 connected? I'm with S block. Connect airlock to V7 column isolation valve, question mark. Except I have more question marks. I have many more question marks. This isn't This isn't how V7 works normally.
It's so weird that it just happened too, and there hasn't been an issue.
A lot of there's cables that go up to the airlock that are like associated with the motor stage and everything we were touching.
Yeah.
So it's like, I'm not personally, I don't feel surprised by this. I'll put it that way.
Okay.
And then there is another, there's the other like airlock wire that like goes down and around. Let me go check on that one.
Yeah, maybe
real quick.
that just got unplugged.
That goes, yeah, and then you've got other weird stuff going on.
Yeah.
This especially stuff's had a weird integration history. Okay, so stuff from the airlock. So this wire also comes from the airlock. This is A11. A11's always one of those ones that when you're like installing 6400 for the first time, I feel like you're like, where does A11 come from?
Oh my god, I remember specifically like
right.
taking forever to find
Find
that.
A11, yeah, isn't A11 fun? And A11 goes just back into the bundle, back into our console there. I don't know where 11 goes after that, but it does something. It's an OM scope thing, that doesn't matter. This A9's present and accounted for. Okay. Let's go back to our schematicing. Have you like always like done like a sample exchange when you turn the Mexico on?
No, I just do it when I exchange samples.
Yeah, some interaction with the WDX is kind of a thing I'm thinking.
You kind of gotta like.
I know what the problem is.
What?
You can close that. Look at the sample exchange.
Oh my god.
So this isn't normal, but this is somebody's added like this feature in.
Okay, well we
did it, chat.
We must have bumped that.
We figured it out.
Okay, well that was fun. At least it was just that.
That's not a standard 6400 feature. It's not a bad feature, honestly, but...
Wait, so it doesn't normally shut V7 when you turn the isolation valve?
No, that's not a... That's not a...
It's always done that, so I just assumed it was normal.
No, that's your microscope special. I'm not like complaining about that, honestly. That's kind of cool. And then I think this button, yeah, this button has also been wired as a V7.
Okay, so you can turn V7 on and off with that.
Yeah.
Interesting. Okay.
So that's why this didn't have anything to do with the pressure setting.
Yeah.
It's because the gauge was good, so the interlock was like happy. It's just V7's been connected to. I don't want to do that right now because it's like this isn't pumped down, but. Lol, that was fun. I enjoyed that. I love a good troubleshooting session. Okay.
That's so funny.
We did it, chat.
Microscope's fixed. We can go home now.
No possible other issues with this microscope.
Yeah, no.
I like how we saw that like V7 like wasn't happy, and I'm like, okay, let's start the stream. Because we got everything ready, and then we noticed that, and it's like, well, we're going for it.
Yeah.
Okay, I'm gonna put the door back.
Okay, I'm gonna get this camera set back up.
That was great. I loved that.
It's fucking hilarious. Monochroma says, I wonder if this used to have Lab 6.
I thought that too.
I did see some notes somewhere in that schematic book about Lab 6.
Okay, because like you don't have any Lab 6 hardware.
Yeah, I know.
You don't have the ion pump.
None of the pumps are up there. It's
you
just
don't. Well, you don't have any ion pump controller. You don't have a Lab 6 compatible crossover pipe. Your spare crossover pipe doesn't have Lab 6. I don't think I've seen a Lab 6 Renault. I've just like usually when a microscope's like had Lab 6, you see something.
There's evidence.
Yeah, I haven't seen any evidence of Lab 6 on this one yet. Yeah. So yeah, it's a little bit more than just missing the ion pump crossover tube. So, okay. Should we turn some lights off and acquire a beam, or do you want? Let's load a sample.
Yeah, we got to get our sample in there first.
Yeah. What's your trick for pulling that little?
You just push your little your finger. You got to get it like right up against the bottom, and then it'll tip forward.
Okay. Okay. Interesting.
Is that not normal to have that?
No, this is weird. So you don't. Yeah, this is like actually an X-ray hazard.
Oh.
Well, I guess not on yours. Kind of.
Because yeah, I can't turn the beam on with that valve open.
Well, you can turn the beam on with the valve open. You just can't have the. You can't have the. You can't have the valve. You can't have the valve open. You can have the beam on, but valve closed. So there's a little plastic disc right here. This microscope basically assumes that X-rays can't leak out this port. And that's true if the gate valve is closed. And that's also true when the sample exchange rod is installed, because the sample exchange rod has a leaded acrylic window on it. That is not true if you have a piece of plastic that fits that. So this is like, is this the piece? Yeah, that fits there? Okay, this is like
no way.
Yeah.
There's no chance.
Yeah, no, that's what this is from, is like this.
No.
I didn't realize that you could use that to like defeat an X-ray interlock on the system. Jeez.
Okay.
Oh my god.
Yeah, that was just when I was sold the system. I was just told that goes there. That's normal.
No, that's just like a cover for the cable port.
Well, it does hold a vacuum.
I'm moderate. I'm entertained right now. This is entertaining. Okay, that's great.
So does that just normally sit open like that?
No, usually you'll have some type of other like thing to block
Okay.
it that's like X-ray safe.
I just get something machined.
Yeah, but not out of aluminum.
Okay. Stainless.
Stainless would be good.
It shouldn't be too hard of a part to machine. It's just a circle.
Yeah, just a circle, and then I mean, you have a lathe.
That's true.
Circle and a threaded hole. Okay, so I'm gonna pull this one out of here.
Yeah, that's just the one
That's empty.
Yeah.
Okay, cool. Just gonna set that down there for now.
Cool.
I've got a stub with a calibration sample on it. That's kind of cool.
Sweet.
So I think we'll use this. So this is actually an FEI calibration sample. Want to do a close-up? We can.
Yeah, let me focus. I have a manual focus right now.
Yeah. Can you turn the ring light on?
Yeah.
This lens has a little light in it. It's so cool.
It's pretty nice.
So that gold circle on the bottom is gold on carbon. There's a Faraday cup in the middle. There's a scale bar for calibration. There's some chips. There's silicon plated and different things. This is used for like dual beams and fibs too. So yeah, it's kind of a cool sample. This one's like a really beat up one, but it works great still. So. Little bit more grease on this, I think.
Okay.
But we're fine for now.
Okay.
It just, I think inside it needs it more than anything.
Yeah, you have to really push on that ring to not let it slip. But we're gonna epoxy that tomorrow anyway.
Yeah. Okay, so we're gonna use the A, I think.
If it's at 39, yeah, I would use A.
Yeah, you can use A.
B is for when it's at 48.
Yeah. So the tabs that are broken off there, those would grab onto that.
Okay,
part,
that makes sense.
And then the reason you would grab onto that is that it doesn't pull into the vacuum.
Into the vacuum.
Pump down, yeah.
Yeah, the dude I bought this from had those tabs
Take
installed.
a picture top
backwards.
down of our sample so that we have like a map.
Mm-hmm.
Yeah, there's a lot of goofy things on this thing. Okay, there's a fair number. There's a lot of fibers on this O-ring. Oh, wow. Okay, you want to get a macro shot right there of that?
Yeah. Let me get focused.
Get real up in there.
Yeah, let me
Bottom left
switch to my
quadrant.
super macro objective here. There we go. Oh my God.
That's what you've been pumping down with. Well, when you've been doing load lock sample exchanges, so it's not that bad.
So sad right now.
Yeah. We do know this microscope has a vacuum leak. It's not that though, because that's not involved in this currently. So.
Yeah, that's fucked up.
Yeah, isn't that fun? Okay.
Focus, hello.
Boop.
Why isn't it focus? Oh, I have it in super macro, that's why. There we go.
Boop. Do you hear the roughing pump?
Yeah, it's not supposed to make that noise, is it?
No, yeah, that's
Oh, okay,
normal.
cool,
That's just your pumping air. 'Cause
Oh, okay.
we pumping load
Okay,
lock.
see, I've heard that happen.
Yeah.
Sweet.
So we got the chillers out of the chiller for this microscope was in this room before.
Yeah.
And this room was like loud.
I had to have a noise gate on my setup every other time I've streamed in here.
We determined that that was causing issues for the microscope, so we moved to the chiller, and we installed our new. You can see it in the wide shot. Our new water filter and flow and valve panel back there, and the chillers are now out of this room, and the room is quiet.
Got nitrogen going for venting too. So, I mean, it's not hooked up yet, but it will be soon.
Okay, I had like mini like heart attack.
Okay.
Because I rolled that valve towards me, and V7 actuated like oh no, vacuum leak. Because normally when V7 actuates, it's
Yeah.
because of pressure. It's
Yeah.
like, oh no, we've
That's
let
so
air
funny.
in.
That was just so normal to me because that's how
Yeah.
I'm used to it being.
39 is
Oh,
actually.
careful! Hold the plastic when you pull it out.
Yep. Good call. Good call. We gotta drop that down. The A is for 48. We got that backwards.
Oh shit!
But that makes
Oh,
sense.
that makes sense. Yeah, I just
Yeah.
had it flipped. It's late.
Am I on the dovetail? I am on the dovetail. Maria, do you remember learning how to do this on my 6400? Nope, I'm not disconnected from the sample.
Yeah, it takes a couple extra rotations sometimes because I think the rod's ever so slightly bent.
Yeah, this rod is weird. Yeah, I don't know why the plastic on yours is so loose. We will get that epoxy. I understand now why it was epoxy before. So normally this would just hold itself out, but it's gonna want to just like slowly move in on its own. Don't
Gonna have to get used to that one.
like it making pneumatic sounds when I do things.
That's just, it's so funny because that's just all I've ever known. Maria said, yes, I'll hold my breath for you.
Okay, sample exchange completed successfully. No need to hold breath. Hopefully we did it fast enough that Maria didn't pass out. Okay. How about I get the lights, and would you like to...
Yeah, the lights are right here,
Oh,
actually.
lights are right here. Wow, that's actually nice.
Boom.
Mood lighting.
Yeah, my LEDs are unplugged right now, so
Sorry.
what are we gonna do?
We can plug like half of them easily.
Nah, it's
but,
okay.
Yeah. Okay. How about... I kind of want to see what you would normally do to get a beat.
Yeah, it's probably gonna be wrong, so we'll see what happens here. So I'm sure I get a good yeah, you got it. Okay, so it's been a few weeks since I've run this thing. Let me just... All right, so I pulled this up first. you just want to start at 5 kilovolt?
Yeah, 5 kV is fine.
Okay, I'm just checking my aperture is right. Looks good. Go to line mode. I put my contrast at like 200 starting out. I don't know if that's too high, but it's just what I found I need to get kind of a good signal.
So that's good. So
Okay.
normally what I do to check the signal path is I'll take it out of LSP, and then drop brightness and then increase contrast or just a little bit. You know, we want to see a little bit of image now. Increase contrast until we see detector snow.
Oh, the high voltage isn't on yet.
Okay. Yeah. So I like detector snow because
Okay.
that like proves out
Okay.
your PMT is connected to your CRT.
Sure.
Because the detector snow comes from the PMT. So if you've done that,
Okay,
you're
so
doing
I'll
like
turn the
pretty good.
voltage
So,
on
yep.
first.
Yep.
And
Good job
then-
checking your film. Good job checking your filament current was down.
Hey, thanks. And then we'll crank this till we see snow. Is that what you're saying?
Yep.
Okay.
Now, we might not be able to do that.
Oh, hey, now I'm seeing snow.
Yeah, we got some snow. Okay, go ahead and do a little bit more for the camera. There's detector snow. Okay, so if you have PMT link on, okay,
Which is PMT link?
photo multiplier tube link.
I don't know if I know that setting.
So I think it's on page 2. It's 3, I guess. Yeah, PMT link right there. Okay, so you have PMT link on. What that does is that changes your contrast automatically with probe current.
Oh my God. There have been so many times. Okay, that makes a lot of sense.
It doesn't change the number though.
Sure.
It does like it does this using the kind of like an analog circuit that's like invisible to you.
Okay. So do you like to leave that on or off?
I like to leave it on.
Okay.
Now the thing to know, if you go back to page 1, what spot size are we in right now? Oh, do you know about the 1, 2, 3 thing, top left corner, or
No.
numpad? If you
Oh,
do
I
1,
can
2,
just do
3,
one?
Yeah.
Oh my God.
Isn't that
Wow,
fun?
this is great. So glad you're here. Okay, we're at 13.
Yeah. Okay. So if you so set that to like 8. Okay. So now try to turn the contrast up and get detector snow. You
I
can't
see.
because it's limiting the maximum or changing your contrast because you're at like a much higher probe current.
Ah.
So if you're in PMT link and you're at a larger spot size, you can't get detector snow.
Okay, interesting.
Yeah.
Okay.
So
So do you want to bring that back up? What's a good spot size to just like start with generally?
10,
10, okay.
12, 13 is a little bit small, but you can get like good resolution. But
Okay.
like,
Go to 10. Still no detector snow though.
yeah,
Go to 11. All right, there we go.
cool. Okay.
So now that we have the snows, when you switch it to line profile.
I mean, you can. Yeah, you can do that.
Okay. Do you not use line profile to find saturation?
I don't go there immediately.
Okay.
Usually, I get like a little bit of brightness on my screen first,
Oh,
and then I
interesting.
switch to line profile because
Okay.
line profile can be deceptive.
Sure. Let me zoom out and make sure my working distance is right. 53 is not right.
It's pretty close.
I just like to roughly, or I usually just roughly
we
set
haven't
it.
moved the stage up.
That's true.
So 53, it's probably right at like 48 right now, actually.
Yeah, okay. Okay, then I'm just going to start
So you
saturating.
want to set your working distance to 48 then?
Yeah, that's what I did.
Oh, okay. Sorry, I was looking at the wrong number.
You're all good. All right, I'm going to start saturating then.
So, yeah, so I don't like to saturate in LSP because it can lie to you. And if you just verified your image is working with detector snow, then you know the second you see anything on your image, you got like electrons.
Okay.
And then the other thing is, if there's a column misalignment or V7 is closed or anything else, you will not see anything in your chamber.
Correct. Okay.
And so you also need to be monitoring your current meter.
Sure, sure. I like to make sure it doesn't get past like the 100, 110 mark usually.
So
but
how far that goes depends on
your voltage, right? Or
filament spacing with the Wenalt.
oh, I did not know
move
that.
the mouse on that one.
Yeah.
Yeah. So go ahead. So I would personally I would switch back out of LSP with L.
Okay.
But if your LSP process is good, then go for it.
Well, I want to see how you think it is. So, I was taught to do this by the guy I got
Yeah,
this
yeah,
from,
yeah.
which obviously.
I do like using LSP. I just don't start with LSP.
So I just slowly start turning it until I see anything. I think I see a little bit of something now. Yeah.
Yeah, there you go.
And then.
That's pretty good. Yeah, yeah, nice.
I'll start looking to see. Okay, it's rising now. Okay, we definitely have some instability modes occurring already.
It's scanning, right?
Yeah, but I think that's that X instability because that line should be like stable.
Can we go back to picture?
Yeah. Oh, yeah. Something's not right. That's new. I haven't seen it do this before.
What?
I've never seen that. Huh. This is not, at least I don't think this is the, let me zoom in. Okay, yeah, this is the, it looks different than it did, but this is definitely scaling with magnification. Let's go down, can I drop the voltage by 0.1 without
Yeah.
Hello? Yeah, that's the issue. It's that above 5K thing. So, anything...
That was wacky. Okay, let's get a close-up of that.
It's intermittent,
I love that.
too,
Yeah,
because...
I love that it's doing it when you first start, though.
If I go back to... Here, I'll go back. It's probably going to be fixed now.
So good.
It might not happen again, but here, we're going to go back to 5K.
Here, just a second. Let me adjust some settings here. Let me pretend that I know how to use your camera.
I think, yeah, just the front wheel for shutter and the back for aperture.
Okay, chat, get a load of this. This one's a good one.
It may or may not happen again, so we'll see. I'm going to switch it now. Yep.
Yep. Oh, look at that. That's so much fun. I love that.
And it scales with magnification, so if I go way in, it just gets wackier and wilder.
That's so much fun.
Okay, but here's the thing. If I turn off accelerating voltage, and if I desaturate, and if I turn it back on and resaturate, that'll be gone. Almost guarantee you. And it'll come back randomly in like the next hour.
Okay.
But it's weird that switching the voltage, that's actually my main instability mode. So if we can figure this out, we fixed a lot of the issues with this scope, at least digitally.
So it's happening in different scan speeds.
And it seems to be more X. Like it seems to be back and forth.
Well, that's because.
Oh yeah, you were telling me about that the other day. Yeah.
Yeah, like that's usually just a scanning artifact. Like if we do our fastest possible scan, it's like, and if we do that plus we do a reduced area.
Okay, and there's another instability mode that's triggered by the right stig knob.
Can't wait to find that one out.
Yeah. We're definitely not like correctly saturated either because we didn't even finish doing that. But that doesn't affect this at all.
So go to RDC. Is that so? RDC is actually, yeah. So RDC is doing a reduced scan area. So this is just about like the highest frame rate scan we can manage.
Monochroma is placing my bet on it being something in the mag power amp.
Monochroma, why? No. That's mean. Don't do that to me. Not.
Maria, we're looking at a pack of calibration samples that Adam brought. A little
Oh, I hit
disc.
freeze. That was a mistake.
Oh.
It's fine. Oh, you're.
I can save a frame. It
Yeah,
does work.
that works.
Yeah.
Sometimes that makes microscope sad.
Hmm.
So what if we do RD?
We haven't reseated the cards yet either, which definitely needs to be done.
So, monochroma, I'm not immediately suspect of. Oh.
We're not saturated all the way, so our beam's probably like a
Yeah,
pretzel
I can
right now.
see that. Look at how this changes when focusing. We've got so many pictures. Like
Yeah, like 3 images.
yeah,
stacked.
isn't that fun?
It's normally not that bad if it's correctly
That's a
saturated.
saturation thing usually. Yeah. Okay. Let's go ahead and carry on with your.
Okay. And now that we can actually saturate without a dance party occurring. Okay, so I kind of bring this scale down just so I can watch the peak behavior. So I'm going to go back down. I'm going to bring it back up slowly.
You're doing a good job at using LSP.
Well, that's good. I still haven't seen a peak yet, but maybe I missed it. Let me go back down. It's
Looking for your false peak.
Yeah, it's really subtle sometimes, I've noticed. Oh, there it is. Wait, no, maybe that's full saturation. Nope. It's hard to say. I feel like sometimes I'm really good at it, and sometimes it's really hard for me to figure out where the false peak actually is. I feel like we have to be saturated there or oversaturated.
Do your gun tilt alignment.
Oh yeah, good point. Well, that was aligned. That was also pretty much aligned.
Okay, so is it going back down then?
What do you mean?
So is it?
Yeah, like if I turn to the right,
no,
it starts.
I mean with your filament with your filament.
Oh, here, let me see. If I turn down, it goes up slightly. It's like here, I'm turning up, 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 up.
Keep going.
Up.
That was your false peak.
Okay, so here is that's our real peak right there. Okay, so then I park it basic. Okay, so if this is our real peak, I'm always confused because I've seen people say different things. Do I want to park it just before the peak, or do I want to park it just after the peak, like there?
Never after.
Okay.
Maybe like at is okay, and just before is okay.
So like right there, basically.
Go back a little bit. Up. Like so, if this is the curve as it starts, so this if this is the curve.
Yeah.
Like where it kind of stops, plateaus, like right there. Like
Okay. So here, that's our false peak going up, 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 and it stopped responding, so I stopped twisting.
Cool.
Okay, so then we want to check our beam with the, or do we want to check and make sure our shape is good with this this thing, emission pattern?
Yeah, we can.
Okay.
That's charging.
We should go to like a flat area, right?
Yeah. If you go to the right, actually, that's the Faraday cup in here. There is some insulator that got deposited on this Faraday cup, so there's like a clean spot like in here.
Oh, okay, I see.
It had something in a fib sprayed on it.
So just like theirs?
Or something to do with, yeah. Go ahead and yeah, we can focus them too.
Oh, okay. Whoops. Stig is really out, but
yeah. Okay. And then if you do
EMP and slow scan.
So
right?
here's a fun one for you.
Okay.
So EOS mode.
Yeah.
Right. EOS mode.
Ah.
Yeah.
Fun. Okay. Sweet. And then we go to slow scan.
Yep.
And I'll turn that off so we can see what's going on. Slower scan. And then wait, why is freeze still up? How do we clear the frame?
I think it's freeze again. We'll undo it. Yeah.
Okay, cool.
Cool. So
right,
you're using the FIS.
Yay!
Whoa.
Whoa. And then I kind of bump contrast until I actually get something. That looks fine. It's not quite in the center.
Yeah. That looks good.
Okay. Call that good for now?
Yeah.
All right. I'm going to turn this back down a little bit before us so we don't get blasted in our eyeballs. Oh, there we go. I don't know what mode I'm in now. Not that one. Okay. So that's a picture. Stig is totally out. I see a grid there.
Yeah. That's like those are scan lines probably from like fib.
Oh, interesting.
Imaging,
That's cool.
Yeah, you're milling while you're scanning.
That's pretty cool.
I would drop your probe current's high right now.
Okay. Drop it down.
Yeah, what's your directive aperture setting too? Is your directive aperture
it's at 3 and it should be at 2.
That 3 is fine.
Okay.
It's like if it was like all the way out, I'd be like, okay, that would explain some of what we're seeing.
Okay.
Yeah.
We also haven't wobbled, so I don't know if it's aligned.
What's our CL? Oh, we're at 7.
So we should go
up?
up?
Yeah. Let's go to like 12 or 13.
Okay.
Let's do, yeah, we do 12. Let's see how far we can zoom in at 12. I mean, we are only at 4.9 kV, so that's zoomed.
Ooh, that looks a lot better.
Yeah, the beam's a lot smaller now. Oh, and then we're also at like a massive working distance.
Oh, that's true. We should probably lower that.
Yeah, or well, technically we're raising the sample.
Oh, yeah. Makes sense. All right, let me do that. One second. I like to kind of focus as I do it, or else I'll lose it. Oh. Whoa, look, when I zoom, magnify a little bit more, that, or focus a little bit more, that starts again.
That might be a charging artifact.
Oh, okay. Let me zoom out. Okay, yeah, I was probably just doing something weird. What working distance would you go to here?
15.
Like 15? Okay. Well, that's definitely not a charging artifact.
That is not a charging artifact.
No.
We're at 4.9.
We are, right?
Yeah.
Well, that's weird. That's never happened under 5 kilovolts before. And it's definitely still scaling. It's the same instability. It's just, if it looks the exact same. What was that noise?
I don't know.
What?
Is that something?
Maybe.
Let me check.
No, I think it was just a relay.
I'm gonna check our chiller temperatures real quick.
Okay, good call.
Okay, chillers are 20 and 20.6, so we're doing good there.
Okay, cool. Monochroma suggested. They said, I wonder if it's a resistor in the mag power amp that's making.
I know.
Okay.
Monochroma has trauma from the mag power amp.
It's really weird that it only happened after a certain mag level too.
Well, it was working distance actually.
Oh yeah, you're right. Not focus, not mag. Maybe the focus is just, yeah, there's like one click there where it just starts. What are we changing from? 60 to, oh, we're not clicking over to it. I hear that.
Let's see here. That's the this seems like stigmator to me, I think, because the stigmator, you have the, well, oh, it's something that's got to have presets for both KV and working distance. I thought that.
But the right stigmator knob does definitely cause instability sometimes. I can't tell if it's the same instability. I don't remember because it's been a minute. I want to say the stigmator instability mode is more like a wobbly. Love hearing the transformer tab turn.
Yeah, that's the bias motor.
Oh.
So working distance and
mag,
working
or
distance
voltage.
and mag. Yeah. Or yeah, working distance and voltage. Interesting. Very interesting. Okay.
Well, this is the main issue I've been having, so I'm glad it happened fast.
Yeah. What do I want to do next?
You could try to swap them. Is the mag power amp board a board? Because I have spares probably.
Yeah, but the mag power amp board is not a board. It is a module down in the water cooled unit.
Okay.
I'm not getting mag power amp vibes yet. I do see kind of why. Okay, you know what? I will. Let me look at the mag power amp. It's possible there is stuff in the mag.
Oh
power
yeah,
amp
I know about the load resistors because I found a previously half combusted piece of paper with Japanese writing on it inside of the CRT when I replaced it.
Okay, mag power amp circuit 34.
I can be the schematic boy. I'm just gonna pop this off.
Okay, so I think it'd have to be like these. So those relays are those relays. And then the other things that come into these. So these are the magnification decade resistor relays. So this is what zooms you out your orders of magnitude.
Okay.
And then, so 1, 2, 3, 4. So that's 4 of our relays, and we have 6 total. So 5 and 6 do. Let's see here. So there's 5. That's also 5, and then that's also 5.
When you say anything click over at 5 kilovolts, what do you mean? Monochroma?
Yeah, that's what I'm seeing if there's anything in here that would click over at 5. The stuff that I know clicks over at 5 is more alignment stuff. Like Stig centering is what like jumps to mind immediately. I think that's 5.
Let me try to cause the other Stig instability mode and see if it looks similar real quick. Just gonna like, I'm gonna pin it to like both of its max range values and see what happens. This is very intermittent, so honestly it feels like whenever I almost get Stig really good is when it starts to happen.
It's just messing with you. Yeah.
Yeah, it's not happening right now.
Okay, so the one that comes to mind is going to be on, let's see here. It's going to be, I think it's LensCont 2 has it, if I'm not mistaken. Okay, so those are our mission pattern relays. So LensCont 2 does like, so these are our Stig coils. These are our source alignment coils. And then these are sorry, correction. These are our source alignment coils, if I'm not mistaken, right? And then I think these are scan, right? I might be wrong about that. I'm pretty sure that's scan. No. Those are shift coils? What are those? Because this is source, right? Because this is source upper, source lower. And that's how it couples the emission pattern in. Actually, that's an interesting test.
Well, and also, again, we haven't actually cleared this, but the way that I've been able to clear this and get it to stop happening is if you just turn the acceleration voltage dead off, unsaturate and resaturate, that will go away. But it'll go away for like 10 minutes to 2 hours. Like it's very random. But just resetting the voltage does fix it.
So here's another thing I'm noticing that's like interesting to me is there's these bands of brightness. Like it's dark and light. And the reason that is interesting to me is that could be like a issue in the alignment coils in the source, right? That could be like with our tilt shifts. So we could see what emission looks like. Checking out emission would actually be easier with OpenBeam.
Okay, should we install that real quick?
We could, because it's like we're a little bit. I see the flickering here.
Yeah, it's happening on there for sure.
Yeah, so the flickering's happening here too.
So it's flickering even when the beam's parked.
Well, the scan coils are. We're scanning the source alignment coils right now.
Okay.
So that's flipping between 28 and 27 millimeter working distance, and we can see it flipping there too.
Focus. Sorry, it's hard to focus on. There we go.
Yeah, OpenBeam would show this better. So to do that, we're gonna to install OpenBeam. We are going to turn off the control console.
Okay. Well, this error might go away, but that'll be okay because it will definitely come back.
Okay, happy to know that it'll come back. That's so good.
At first, I thought it was like something heating up because it would only happen after it had been on for like an hour or two, but obviously it just happened on first boot, so.
It had been on for a little bit.
That's true. But I've noticed it happen like within 5 minutes of me sitting down and getting it on.
Yeah, it happens with working distance and with accelerating voltage. Okay, so
You want to turn the console off?
Just let me just schematic just a little bit more.
Sure.
Okay, so what we got here? So this is our lens drivers. So that's our clear relay. So that does our like hysteresis correction. That's our.
I was checking to make sure the GoPro wasn't locked up.
This is our reference voltage generation circuit. That's got a DAC in it. Our reference voltages are used in they're summed into all of our lenses. So condenser, objective. So yeah, it's summed into our condenser, our objective. and our reference voltage gets scaled with kV. I'm trying to think if it gets scaled with working distance or not. It might. So we can check. We'll check test points there for the instability.
Okay.
Yeah, it's hard to say if we actually have like focus instability or not.
Somebody, when I first posted this issue like a year ago, I forget who it was. I'll have to go back and look. But one of the first suggestions I got was a bad DAC.
Yeah, bad DAC would potentially make a lot of sense.
But I don't have the electrical engineering knowledge.
It's just like put an oscilloscope on it, basically.
Okay.
I don't think that gets changed with. I don't think that gets changed with working distance.
Monochroma said voltage reset fixing it, could it be instability in the HV tank? That was my first gut thought when I had no idea about any of the parts in here.
The question is though, why would instability in the HV tank be sensitive to a 1 millimeter change in working distance?
Yeah, it seems too. Before I saw the.
Yeah, we don't. So basically, we don't know if this is a digital or an analog issue yet. Okay, so this is lens I/O. So this is like take all the ones and zeros and turn them into reference voltages. So this is like a lot of DACs on here.
Okay.
Like DAC, 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 DAC. Well, is that? Yeah, that's a DAC.
Hear that.
So there is something clicking. Like there's something clicking when we cross over there.
I wonder if we'd hear it better with the front panel off.
You probably would. You want to pull the front panel off?
Sure, I can do that. Should we shut the console off first?
For front panel, I usually don't. It's pretty okay.
All right. I have pulled it off while it was running before. I just want to make sure that was actually safe.
Yeah, I mean, if you drop a screw, it's not good. But
well, yeah. They're only on the outside though, so.
Yeah.
All right, I'm gonna just set this camera over here for now. Is your JEOL screwdriver? Boom. All right.
Yeah, the brightness change is so substantial even in this.
Yeah. Can I sneak?
Absolutely.
Well, that went somewhere.
What is going on?
Yeah, I was waiting for you to see that. The frame integration system has some interesting adapters on it.
Why is there paper towels in the FIS? Why is there white powder on top of the power amps?
I don't know.
Why is there brown stuff all over? What is... What? What is going on down here?
This is the state I received all of this in, so.
So much fun.
And as my first sem, you know, I look at some of this shit and I don't know if it's normal, so.
No, I mean, it's kind of. Usually you clean it out though.
Yeah. Well, I hadn't focused much on cleaning this section yet. Again, after I got it working and put the panels on, I kind of forgot some parts of it were dirty, so.
I see. I am searching for the flashlight.
Oh, it was, yeah, I thought it was back.
Yeah, I thought it was too.
Maybe
Thank you for the flashlight, monochroma. I haven't actually lost it, I swear.
We just had it. Yeah, I gotta take a sip too. I'll be right back.
Sounds good.
Dr. Pepper break.
We're like using it very recently too. Recent?
You brought it back and you leak checked. When I was doing the KF adapter, you had it shining there.
Yeah, I remember that. That's why I just checked over there. I'm holding a flashlight. We'll find Monochroma's flashlight in a second. I'm sure
we didn't lose it.
This won't concern Monochroma at all. 11:45. Okay. Oh, that's just straight up like mouse turds. Cool. Great.
Yeah. All right. I will wipe this out.
Yeah. So there's a limited amount of poking I'm willing to do right now.
Yeah.
What?
My transformer was slowly leaking when I first got it.
Okay.
I think it stopped.
Okay. That's so much fun. And then up here too. Like there.
Yeah. Oh my god, I didn't even see those.
This is what SEMs look like when you get them frequently. Spent some time this week cleaning it out of that side.
Yeah, I just forgot there was anything in here. Or I would have done that too.
Why is there a paper towel in the FIS? I don't get that.
Okay, I have a prediction. I don't think that side panel on the right is fully attached.
It's not. You're correct.
And I think they put the paper towel there so nothing's shorted.
Okay. Yeah, no, that makes sense.
I hope this is at least entertaining.
No, this is.
No, the cards haven't been reseated yet. I haven't had time to do that yet.
Oh, another dead spider.
Ooh.
It's like the same.
Maybe that's our problem. Maybe we need to put.
That I found in the chiller too.
Maybe if we put in a live spider in there, it'll fix our issues. Maybe the problem is that the spider died. Maybe it was an integral part of the machine.
Machine spirit. Okay, so U15 lens comp 1 and U12. Isn't that lens comp? What is U12? So these cards that have like a lot of potentiometers in the front, those are ones that have like a lot of like presets that like change when you change different things. Okay, here, let's put this back into normal mode. Still doing it. The brightness changes is something that's getting me, because like if we go to waveform, well, I guess Really, we don't want waveform. We want LSP. The brightness changes.
What do you mean about the brightness changing?
Well, some of this is beam. Some of this is the beam moving. It's hard to see. It's hard to like resolve. But like you see the horizontal stripes.
Yeah.
Like those stripes, right? That's like
Yeah.
that's more than just beam displacement. That's like beam current might be changing.
Hmm.
In fact, you can see where like beam current's dipping.
Yeah, just pockets of it. I always assumed that was just like the beam being deflected very hard in that one spot or something.
Yeah.
Like
it seems like it seems like we're actually changing. It seems like we're actually changing. My camera needs a battery. It seems like we're actually changing beam current. Oh, Maria recorded the time we started looking for the flashlight, and then we just abandoned it, never found it. Tell you what, I think we're gonna put OBI on.
Yeah.
I'm gonna listen to where the relay is clicking. That's what I'll do.
That sounds like a good idea. I don't think it's happening yet. Scan looks normal right now. So right when it crosses from 60 to 61.
From 28 to 27.
Oh, I was looking at course.
Course is a good look at too, though.
I wish there was a such thing as a sound camera.
Yeah, that might be from the Mag Power Amp.
No.
Okay. That's cool. Not at all. Yeah, touching the Mag Power Amp was awful. Okay.
That's not something we have an extra of either, is it?
It is not. There are such things as sound cameras. Monochrome is correct. Yeah, we do have a probe current detector. We can do what you're describing. We also have a Faraday cup right here, so we can also do it that way. It might be coming from my power amp, but I'm not getting my head close enough to anything to find out because I don't want to touch any of that.
Yeah,
so.
no, that makes sense.
Let's go ahead and ramp the control console down. Let's go ahead and plug open beam interface into it because we did say we were going to do that this stream, and I do want to do that.
Yeah.
And then let's find out what's going on tomorrow.
Yeah, I think that's a good idea.
Cool.
Is Mag Power Amp rebuildable with tools we have here, or is it?
Yeah,
Okay.
but
But it's going to be a fucking pain in the ass, basically.
And it's going to be a more time too.
Yeah, that's what I was figuring.
Yeah. But it is doable.
Okay.
But it's a lot of work.
Yeah, sure.
It's a lot of work. It's so much fun. I love the mag power amp so much. The hard part is like getting it out, and then if we touch mag power amp, we're gonna be touching the water cooling line is gonna be mag power amp, and then all those are gonna need new O-rings because like they're all gonna leak the second we touch them.
Jesus.
So I'm really hoping it's not mag power amp, but
that'd be nice.
Yeah. I might just have like Monochroma ship me one because and then I rebuild it. My shop. So yeah, let's. You wanna go through your shutdown procedure?
Yeah. So, yeah.
This is.
What?
Monochroma's making a very funny joke. You wanna know what? You wanna know why the joke is funny?
I don't.
There is no LEDs in the mag power amp.
Okay, that makes sense.
There is LER sometimes.
What is that?
Light emitting resistors.
Oh.
When things really go bad, it starts glowing.
Interesting.
Okay, I'm putting gloves on so I can touch the mag power amp, and I'm going to take the little panel off, and we're going to see what's behind the little panel. Okay. This is so much fun. What was it?
I'm sorry it's gross. I just totally forgot about that.
Loose. No problem. Can you click into the range where you have a problem?
Yeah.
So one click to the right on focus, I think. Or,
There you go. Oh, whoa, what the fuck? That's new. Now we're getting even more fun. Flashing. Oh, my camera just died. I gotta go swap batteries. I'll be right back.
sounds good.
At least I think it died. Yeah. All right, be right back.
So I'm looking for anything I'm doing, like touching, to cause some kind of change.
Sure.
So this panel is access for the scanning. Okay, I don't see any glowing, so that's good. So this is like some scan coil adjustment access. And I do think these also have ranges they go through.
Okay.
That might be associated with working distance in kV. Can you click it back and forth?
Yeah, here. It's weird to me too that if I just disable HV and turn it back on, it'll just be fine.
Part of me's not that surprised for this type of issue.
Okay.
I think once we find out exactly what it is, it'll make sense.
Sure.
This seems like a pretty satisfying issue to figure out. It's just like, it's got like such a specific set of symptoms. We've got the, just like, oh, we can change one little thing and it goes in and out of like having the problem.
Yeah.
But like, it's gonna make sense when we find it, I think. I can't, it doesn't sound like...
It almost sounds like I hear it more reflected off the window.
Yeah, it
back
doesn't
there.
sound like especially loud coming from the mag power or coming from this
Here,
box.
can you flip it and I'll go listen to the HV tank? Because it kind of sounds like it's coming from the back.
Absolutely. Just give me a second here.
Cool, no worries.
Actually, I'm gonna change my gloves first because like.
That's a really good idea.
I just touched the thing. Can I get a little container for these screws that's dedicated just for the screws that are from the thing?
Yes, from the thing. Here you go.
Also put the screwdriver that has been used on the thing in there.
Okay.
And then we can spray it all with ethanol. And all of our problems will go away.
Will do. All right.
You're a little bit tangled up in, oh, that's your HDMI cable.
Mm-hmm.
Okay, so very carefully split this open.
Yeah, here. Flipper again, let's see. It's coming from back here.
Yeah, I agree.
It's coming from the right, though.
Can you flip it?
Yeah. All right, here. Sorry, I'm trying to get the frame rate better. Okay, flipping it now. After I focus. Okay, now I'm flipping it.
Yeah, it sounds like it's coming from the lens board area. So
Well, that's good, right? Because that means it's easier.
yeah,
potentially.
I would say that is probably a good thing.
Okay. Yeah, it's giving me one of those top left cards. Is what I want to say. The brightness is really consistently dropping now. Let me know if you want me to stop. I'm just clicking it a lot for now. Yeah, our brightness is dropping by probably half now when I do it. And it's flickering much, or the brightness is flickering much slower.
Let me know if this changes it. Ready?
Yeah.
Are we in the mode?
Yeah. Yep.
Anything?
Wait, I had it in the instability mode, so I think I might have just been tired and dumb. Can you try again?
Is it in instability right now?
It's out of instability.
Put it in instability.
Okay.
Are we in instability?
Yep, yeah. Did you just touch something?
Yeah.
I saw it, yeah.
Is it unstable right now?
Yeah, every time you're touching what you're touching, the brightness like doubles. And it goes actually back to the instability mode.
Is that affecting it?
Yeah. Yeah, it's almost like microphonic.
Okay, cool.
So what is it? Well, it's much more unstable now.
Do it.
Okay.
Do it again. Yeah, that's the what's the technical name for that? It's like in the detector chain actually.
Oh, really?
Yeah, I think that's the collector box, right? Oh, yeah, no, that would make sense.
So is our collector dirty, or?
No, this makes sense. So it's the so the collector automatically like compensates for working distance and for accelerating voltage.
Oh.
It has a shitload of relays in it. Right, that's what this one is, right? This is the K box. Okay, cool. That's an easy one.
Yay! It's not the mag power amp.
Yeah, if it is the collector, which I think it is. The collector's got a ton of relays in it. It does sound like it. We're not gonna fix it yet, though.
Sure.
I want to get a video of it using OBI.
That'd be really good.
Um,
Cool. So let's install OBI then.
Yeah, let's install OBI.
Let me get my tripod set back up.
Cool. Okay, collector. So the collector is like. Or actually, I want to have you tap on the collector box. So I want to see what it looks like.
Yeah.
Yeah.
Can you show me where to tap?
Absolutely.
Let me set this back up. Yeah, it was definitely like getting way more unstable the more you would tap.
I love finding the right place to tap.
Okay. Oh, is it the thing on the right? Like this thing?
Yeah, but don't tap the bottom of it. Just like center, because the bottom has some high voltage coming into it.
Okay. Just like tap the side of the panel.
I was going. Well, I was in the middle of the rectangle, but at
Okay.
the bottom of the box where the cables
That's
come
where the high
in, that's where the high
voltage
voltage is. Yeah.
I'm gonna tap it. Are you ready?
Yep.
You seeing any?
It's hard to say if it's completely correlated or not.
It definitely picked up when you started tapping it because it was pretty.
Yeah,
it was
it's
semi.
like picked up quite a bit now.
Interesting.
Yeah. Okay. I do think the relay click is in the collector. Just the tape for that cable. Cool. Let's ramp down. Let's get OBI on it.
Okay.
Okay, part 2 of the stream. Open beam
Yay.
interface.
Well, I'm glad that the issue I was having started so very immediately. Because sometimes it takes a couple hours.
Yeah, and actually, go ahead and resaturate it.
Okay. Just eyeball it, or?
Yeah. So you can actually change the collector. So go to like page 3.
Oh, I see collector.
Yeah. Turn the collector off. And then we gotta turn contrast up. And we also gotta turn probe current up. I'll take us out of PMT link because with the collector off, PMT link calculations
okay,
are
that's on
inaccurate.
2, right?
No, it was right there.
Oh shit. Oh yeah. Ah! Our poor tube. Yeah, the instability's gone. Shit. Okay. Well, that pretty much confirms it. Wow. And the image looks actually not horrible. Stig is way out, but I'm glad to see that it takes you just as much random spinning of these to hone in.
The sample's a little bit challenging because it's like, it's got its own details kind of going on.
Sure.
Or because it's got like these features that are like masking where fully focused is and masking stig issues.
Gotcha.
So we can go to something way easier to
So we
focus
pretty
on.
much know the issues in the collector now, right?
I mean, with the collector off, the issue went away, so
So-
I like our odds.
So with the collector off, what are we? Does that just mean there's less of a bias applied to that cage, or what?
Yeah,
Okay.
so this is like probably a lot of backscatter right now.
Okay. Wow, that looks cool.
Okay, let's fully saturate real quick.
Okay. Can you give me a line profile?
Sure thing.
Thank you. Okay, that's definitely our false peak. That was a weird looking peak.
It's because of what the sample is.
I see.
And the beam is moving slightly as you saturate.
There you go. Let me just double focus. Second guessing myself.
I've turned the lights off out there.
We can't turn those lights off. They're permanently stuck on. But I'm getting blinds installed for that reason, so.
Okay.
Yep. Yeah, those are like the security lights for the floor. It's very unfortunate.
What spot size are we at? Oh, we're at like spot size 6. That's,
Oh, that could be a part of our problem.
yeah. We're just gonna...
Whoa. Yeah, there's some more detail. Damn. Stig is definitely out still.
Yeah.
Still a little out.
Yeah.
There we go. What's DMAG do?
Oh, didn't want to do that. So DMAG does, it takes the whole thing and just scans like the small area.
Oh, okay. So it's like reduce scan?
Yeah.
Okay.
Well, no, it's not reduced.
Okay.
Reduced is different. But that should cycle through reduced. Doesn't one of these cycle through to reduced?
It's the pick button. If you press that.
Oh, it's right. The pick does reduced. Yeah, there we go.
Is that gold on carbon?
Yeah.
That's cool.
It's a great test specimen.
Yeah. I need to get better test specimens. I have a really shitty old calibration specimen, and that's it.
Like calibration for what?
I don't even know. It just has bars on it. It said calibration specimen on the bag.
Oh, like bars for distance?
Yeah. I don't know what the scale is, though, because I'm missing the sheet that came with it, so.
Nice.
Yeah. It's fun to look at, but pretty useless.
So we're at 23,000 times magnification right now. So for only 4.9 kV, this is like not bad at all. Oh, we can probably take the kV up now, right?
Yeah, that's true.
So it's changed focus completely.
Sure.
Not really completely, just like a little bit, but on small details, it's like...
Yeah, you...
I'll increase the probe current, help us focus on... It's like, it's kind of, it's with how much, with how bad our signal to noise is because of our,
The collector.
yeah.
I didn't even like realize you could run the PMT without the collector, but I guess it makes
Well,
sense.
the collector's just the grid on the outside,
Yeah,
right?
so it's, yeah. Stig is way out again. Stig is probably going to be messed up on every different kV level. So that sound isn't the transformer tap. That's what you said.
That's it's changing what bias resistor is being used.
Okay.
Okay, go ahead and check our saturation, please.
Sure. Whoa, something weird just happened. Okay.
Yeah, it's gonna kind of move around as we do this.
All right, I'm gonna turn it back up now. False peak. Wait, why are there like 5 peaks right there? So it's like desaturated now. I'm going up, up, still going up, still going up, bouncy, still going up, still going up. Okay, that's saturation here. Let me, there.
Saturation, okay. So you see that?
See what?
There's like a jagged line that happened.
Oh no, I didn't. Oh yeah.
Oh, that, yeah. It might have been me touching the stage, so I don't think so, though. That was probe current there.
I've done that before. Oh wait, no. I thought you twisted it by accident. Which I
Oh,
have done.
I did twist probe current by accident.
Yeah, I've done that so many times. That's weird. Okay, that's the other instability mode. That's usually triggered by when I fuck with the right stigmator. In fact, if you fuck with the right stigmator, it might even cause it to get worse. Yep. Could that be low flow to the objective lenses?
I don't think so, no.
Okay, okay.
That reads like, just off the bat, just kind of looks like charging right off the bat.
Oh, just charging? Okay.
But, yeah.
Yeah, that like flickery. And it seems like when you get closer to the end of that range on the stick, it gets worse. Like the extremes seem to make it worse.
It's like a mirage pattern almost.
Whoa.
I don't have PMT link on.
Yeah. Whoa. Yeah, there we go. So that's charging, you think?
That certainly
Yeah.
seems like it to me.
Okay. Well, then maybe it's not. Maybe there's nothing wrong. Maybe my samples have just been charging up.
No,
a
no,
lot.
that in the column.
Oh. What would be the cause of that?
Piece of dust.
Okay. That sounds about right. You've seen the pictures of my gun chamber. If there's not dust in the column, I would be surprised. Especially after seeing the fucking O-ring right there.
And then,
Whoa.
yeah, it
Totally
seems,
inverted
it seems
just
like
now.
stigmation is like kind of moving or being around in the column.
Yeah, that was kind of my prediction, is that it's like hitting a piece of dust at the ends of its range. Okay. Well, dust is also an easy fix, right? We're gonna be cleaning all this shit anyways.
Yeah.
So, do you feel good about the magnification performance? Do you think it could be better? Like what? It was way worse before I cleaned the upper optics.
Yeah, it's not
But
the worst.
it's not the worst. It's not where it should be though, right?
Yeah.
Okay.
I don't like these stage drives. So like
Yeah,
I've got
it's really
I've got
annoying.
really good control of the y-axis one.
Yeah.
So these need to go.
Those are the motors for the.
But it's something that mechanism is making this stage hard to control.
Yeah. There's too much like slack in it, so it goes.
Backlash,
Yeah,
yeah.
backlash. That's the right word. Yeah, I'm probably gonna take those off and just build my own stage controller, anyways. So
I like that plan.
mine probably won't weigh 50 pounds either. So
I like that plan too. Yeah, this is a routine OBI to really be able to.
okay. Well, let's get it installed.
But it's not doing terribly. I haven't seen like serious flagging yet. I mean, A digital imaging system could definitely help
Yeah.
resolve flagging more.
I never
So-
even really saw the flagging on this screen. I only ever saw it when I was using the.
Do you want to
4Pi.
like show the 4Pi real quick?
Sure, we can boot it up.
Yeah, just to show what we're going from. What camera are we down right now? I think we're down.
Oh, it's your stream. You probably just have to turn.
Oh, the computer. Yeah.
just reconfigure the properties because I think it went to sleep and
Yeah.
those like go into a weird low power state when they lose signal.
Yeah.
Or like even if you just reconfigure the OBS cam, it'll reboot. I think. Wait, why isn't my computer? Oh, I forgot I unplugged all the shit up here. 1 second. Yeah, I think we'll get OBI installed and then call it a night. Come back fresh tomorrow with many new ideas.
Yeah.
Honestly, like I feel a little hopeful because it feels like not quite as bad as I was thinking it might be so far.
I mean,
Just- don't
cleaning
wanna
the
speak too
column
soon.
can be pretty intensive.
Yeah.
So.
But I also feel like
What
it's
is that sound?
this thing. There's a fan in it.
There's a fan in it.
Yeah,
Okay.
it's a fan.
So 4Pi. You want to talk about 4Pi a little bit?
Yeah, I mean, I don't know too much about them other than that they haven't existed since like 2005, and they built this nice little box here that connects to a PCI card inside of this Windows XP computer that takes over.
And it's
our-
labeled 8600. Did
Yeah,
you
I
notice
noticed that. I think
Okay.
somebody might have been, I don't know, wrote it backwards. Did they make an 8600?
Yes, that is a micro probe, I believe.
Okay, that makes sense.
Oh, I'm out of cable.
Oh,
Thanks.
tragic.
Almost.
But
I must show the chat the PCI cards
yeah, so
and the
we're
license
plugged
keys.
into this like little guy just hanging out of the back of the computer here right now, which goes to this cable, which I don't know what it does in there. I'm not an electrical engineer, but then it goes here to JA2, which plugs into the microscope and actually drives the scan signals.
So that's all your scan signals. So this box is basically being replaced with.
Yay,
You want to hold that?
our new baby. Beautiful board design, by the way. I love
Thank
this.
you. From Windows XP to MacBook or Linux or whatever you want. Or Windows, I guess, if you want.
Very awesome. I'm excited. Ooh, look at that. You even got some fancy stuff on the
Yeah,
back.
there's some graphics there.
Nice. Very cool.
Okay.
Really cool. Very fancy.
Ah, yes, the green rolling hills. We love the green rolling hills.
Yeah, so I can show you how this works real quick. It's,
Yeah.
it's not anything crazy. Okay. So first we gotta open the software called Revolution.
4Pi Revolution.
Mm-hmm. Right, I'm going to take this back to normal scan mode real quick. Okay, so now we have two different modes. We can hit preview, which will take over and drive the scan coils, and I always need to adjust brightness and contrast going into this because it's never quite bright enough.
There's a way of making that match.
Yeah, I think it probably needs
Yeah,
to, the gain
yeah.
needs adjusted over
Yeah,
there.
Well, it's not going to be.
Exactly. So now we got the image scanning, and this is just preview mode, so this won't save anywhere.
Is this the fastest it can scan in preview?
No. The fastest it can scan in preview is if I go to 64 by 64. We can get a pretty quick.
So that's how fast you can do live scanning on a computer right now. is If you do
Yes.
64, and there's no shorter dwell time or anything?
Okay, I could probably lower the dwell time to like 10.
Yeah, that'll speed your scan up.
There we go. So that's
Okay,
probably
so yeah,
like
do like a 512 by 512 scan.
512 by 512. That'll
Yeah.
probably take about a second per frame. Nope, more.
Then go ahead and do dwell 1.
Okay. Is that 1 nanosecond?
That's 1 dwell unit.
Okay.
Or okay, well it's dwelling for less, but it's also still scanning slowly. So I guess it's just throwing away data. I don't know. Oh, do a single 8-bit.
Single 8-bit.
That'll get. And then it's transmitting. Go back, and then this uncheck EDS. Uncheck channel. Uncheck that one too. Yeah. And then channel 1 SCM versus full range. Well, okay. You can put that back. Go ahead and enable channel 1 again, and then click OK. Okay, I want to get this thing like a best shot, like.
If we want to like actually take a good picture, I can.
I want to see how fast it can scan.
You've seen it.
Well, I think maybe there's settings.
Maybe, that's a lot faster.
Yeah, but like, it's not useful.
Okay, there's 2 settings panels in this program. It's okay if the program didn't just crash while it was driving the microscope. Fantastic.
Love that for us.
Okay, the whole computer just had an aneurysm, but it's back. No, I take that back. Okay, I just have to turn off the preview. I think there was so much frame data coming in, it was literally just like...
Yeah.
Okay, there's this settings window.
Yeah. And
then I think there's... Okay, the options doesn't do anything. That just does nothing.
Nice. Love that for us.
If you go to edit preferences...
Okay.
This is where you can change your comments on your image. So every time you want to change your comment, you have to edit the preferences for the entire program. And then there's some scan generation settings here.
Oh, let me read that. Okay, so there's the retrace, pixel delay, line sync, park beam at 0, scan blank polarity, input channel setup. So the retrace could add some delay, maybe.
Okay.
Maybe set those to. Maybe set those to 1. That'll be fine.
I mean, even if we break it, it's okay at this point.
And then SCM line scan. I'm just curious what's there. Oh, change that acquire to. Oh, I bet I know what's going on. Change that acquire to single 8-bit. Or maybe dwell 8-bit, actually. Maybe we should try dwell 8-bit for everything. Okay, cool. Are these saved?
Yeah.
Go ahead and close it. And then let's.
Yeah,
and then go back to the settings for this. And then uncheck show line profile.
Oh yeah, I hate that.
Yeah, and then so uncheck EDS. Set to dwell 8-bit. Yeah, see what this does. And then let's go 512 by 512, so we have kind of like.
Still slow as fuck.
Okay. Maybe there's ways of speeding this up I'm not seeing.
But yeah, it's pretty slow is the point.
Yeah. Yeah.
The best resolution we can capture at in preview mode is 1280 by 960. This is the best resolution we can preview right here. Yeah, there you go.
So we seem to be data rate limited because it's like, it can go, like, say it's like 10, like dwell 10, it'll probably be the same speed.
Yeah, you're probably right.
It's a little bit slower.
It's definitely slower. Whoa, our instability just started back up.
Yeah, that looks like charging. I mean, charging kind of random sometimes.
Okay.
I think it's charging. I don't have enough data to say that for
No,
sure.
you're right, because the instability has a lot more like potting and those brightness drops, which I'm not seeing. And it would have kept doing it, so.
I can turn the collector back on.
Yeah, well, that would cause more instability, most likely. But yeah, even if we want to take a really good image, I can do a 4K capture, and what mag are we at?
9500.
Hello? Okay, it took a second there. This computer is being so slow today. It's not normally this slow. Okay, whenever this thing drives the 4K scan, it never makes a good image. It always does this kind of shit.
Oh, you can zoom in on the frame buffer.
Yes.
That's a rare feature, actually.
Really?
Yeah.
Well, I use it all the time.
No, it's great.
But it stopped now. That could also just be charging, I suppose. It's actually, since the beam is moving slower, it would be more prone to charging, right?
Potentially,
Okay.
especially on the sample.
Okay.
But this sample is not charging most likely.
Okay.
You're dealing with like charging causing beam deflection in the column more
Okay.
than we're dealing with like a sample charging.
Okay, gotcha. Oh, I keep forgetting, because I've only ever heard charging in the sample context.
Yeah, because usually the column's not full of stuff.
Usually.
Map Labs, the sample is gold and carbon. Okay, well,
Well, that was fun.
goodbye 4Pi.
This was 4Pi, and it's going away now, so I'm going to turn this off.
Are you sad?
No.
Okay.
I'm going to use this to play pinball. That's it.
So I'm going to ramp the beam down now.
Sounds good to me.
And let's see here. What are we down? Oh, that cable's unplugged.
Oh, well, that'll do it.
And then probably
Here.
need to.
Probably, yeah, I'll just reinitialize it real quick.
No, I think it's.
Oh,
I think
okay.
it just needs to be signed in. Yeah,
Yep, sweet.
that was Mac doing Mac things.
I got to take a Dr. Pepper sip.
Okay. So we're gonna ramp the console down. For those of you just joining the stream, this is the Biomnemonics 6400. We are in the process of. We did some diagnostics on it. We had a couple of we got two distinct instabilities. One instability, current working theory, is charging. The other instability, pretty well proven out, is something in the collector voltage controller, kind of loose connection, DAC, something. You go to certain settings, collector voltage gets very unstable, causes changes in image brightness. Because the collector cage, right, collector cage is in the sample chamber,
Yeah.
it affects how many electrons you collect. It also deflects the beam.
That makes sense. So if the voltage is really unstable there, it could be just moving the beam all around?
And changing brightness simultaneously.
Okay.
What is Map Labs? It might be a TED pellet. This is an FEI one, FEI calibration sample. Okay, so we're gonna go beam current down, acceleration voltage off, and then I'm gonna use the switch back here to do OPE off.
Sweet.
Okay, we are OPE off. Now, remember, still got AC in this box.
Yes.
So be
still
careful of that.
energized. Cool.
Such a fitting hat.
Right? I know. It was just the Sem's birthday a month ago.
Okay, so I guess we're just gonna take this out completely. Take out 4Pi.
Yeah, we can just get rid of that shit.
Yeah.
Save ourselves some
monitor.
room. It's not still in this. Yes, it is. Okay. Jesus. I'm gonna check our chillers just for fun.
Yeah, especially because we just commissioned a new one. I wonder what this little box is for.
2020.
What do you power?
Nice.
Oh, this is the monitor power supply. Okay,
Yeah, they are both happily at 20.
nice. You want a handful of power monitor cables?
You know it. Thank you. I know just the box for these.
Boop, 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 boop. Well, that was some fun diagnostics. I love microscope diagnostics. You know, it's like
Yeah. It's especially fun when we actually figure out what's probably wrong with it.
right. I do love actually figuring out what's wrong with the microscope. that is the best.
My
feeling.
diagnostics usually don't go that well. Shit.
Oh, you okay?
I'm good.
Okay. We got
Camera good?
Camera's fine.
All right.
That's why we have this HDMI strain relieved.
Exactly.
Yeah, I'm much happier with the HDMI stuff than the UVC stuff.
Yes.
Do we have the driver handle back here still?
Yeah,
No?
it's back there.
You know what? We got this one. This will work fine.
Oh, okay, I thought that's what you meant. Oh wait, this wasn't connected to SM57. I was silly. It was connected to this card. Wow, those. I guess I must have used a screwdriver. Thank you.
So this one we're undoing right now is the analog that goes to the microscope.
Make extra sure I don't trip over a cable this time.
Yeah, you have a few of them out. Okay, that box is free for you.
Yay! I get to keep
And
it.
then I'm gonna come down into the console here. Get a good shot here. And we're gonna pull out the cable from JA7. So that's right.
Did you know, caution, when installing the 4Pi digital imaging system, set the CRT display on the EM to lowest possible intensity.
Yeah, because if the beam stops, you'll burn the phosphor.
Oh yeah.
Okay, so JA2 is out.
Okay, cool. Now we just need to disconnect all the BNCs, right? It might be easier if we take
those
these.
because
gotta take this off.
they do the thing, the monitor. Oh, you did not use. I see. Interesting.
So the problem was these were off for so long, I lost like all of the screws.
Yeah, these are the standard drill panel screws. So we also need to get you more standard drill panel screws. And
Yeah.
yeah,
We need to probably just order a bag of those because I think I lost like
Yeah.
3 this week already.
nice. That's how it goes sometimes.
Okay, I'm gonna go get a screwdriver that doesn't have poop on it.
So that should be the size of that. Yep. Not the right bit. I don't have the JIS Phillips bit back here, so let me go grab that so I can not strip the drill panel screws. There we go.
Oh, you had a screwdriver. Nice. Well, we have more now.
I'm just putting these in the yellow bin on the left.
Got you. I got it.
Cool. Okay, so the way this works is this one interrupts the BNC that goes to the NA7 doesn't exist. I see. Unless it's just dangling somewhere.
I remember NA7.
Yeah, it might just be dangling. Yo, look. Look at that.
Boom.
Guessed correctly. Okay, so we're also short a JC1.
Another name I also remember.
Yep. Not surprised. So that's K1 right there from the detector itself. And then is that JC1 right there? No, that's unlabeled. Okay, that goes to the front there. That could actually be JC1. So if we pull JC1 out, we're gonna lose our. I'm pretty sure we're gonna lose our CRT if we do that.
Okay. I have a splitter.
That shouldn't be necessary.
Okay.
Well, okay, we actually. So I'm gonna go and take JC1 out. And then let's see here. There's two other cables here. So what do we got? We got one goes there. Where does our other one
take
go?
this panel off too.
We don't need to, but we could.
Okay.
And then this one is our AUX video. Okay, so we'll go and pull NA7 out because we know NA7 well. So that should have freed up that. Okay, so this was taking NA7 and feeding it to. Does NA7 go straight to JC1 or does NA7 go to the front? I'm trying to remember.
It's been like a year since I've worked back here.
Okay, I really need to know where. I need to remember where NA7 because I thought NA7 went to the FIS, but I'm working from memory here. Okay, so that is our 4-pi cable removed.
Sweet. I'll add it to the stack of other 4-pi cables I have.
Okay, so OpenBeam is going to interface in 2 spots here. So OpenBeam is going to connect to NA7 here. And so NA7 had one cable in it, and I do have an NA7 cable here. I'm just trying to remember, the other side of NA7 goes to FIS, or does it go back up to our CRT? I kind of thought it went back up to our CRT. To do that through JC2, is that what's happening? Oh. Okay, so that one and this one. Okay, so this one, so NA8, yeah, NA8 goes to FIS, and then there's also this one here, and that is up to, so that's JC2 and CRT2, and so this is how the FIS gets video data up to here.
Oh, okay.
Oh, there it is. There's the
it was
original.
just
There's the
jimmering.
original JC2
Yeah.
or JC1. Okay, so original JC1's been restored on this end. The other end probably wasn't unplugged. And then we'll go ahead and restore NA7 on this end. So right now, so after we've removed the 4 pies, we're kind of returning the microscope to more of a stock configuration. Okay, let's just boot up and test and see if we get anything on CRT1 right now, just so we know if we got our signal chain correct.
Cool. Oh.
And OpenBeam doesn't actually replace the signal chain. It's the way I've got your install kit configured. It just taps off at NA7, so it wouldn't actually kind of do anything really.
Okay.
Okay, so we're OPE switch on now.
Yeah, OPE is on. I'm gonna switch this. It's crazy to me that this scope is on and it is not 1,000 decibels. I'm just so happy the water chillers are out of here.
Yeah. Okay, we got signal.
Cool.
So you can change brightness and contrast.
Yeah, it's working.
Cool. Okay, we can go OPE off.
Okay. I went to look for it on the where it normally is.
And
all right.
watch out for inside the box.
Yes.
Okay. So,
What you looking for?
let me grab you some cables.
Okay.
NA7 goes to JC1. So that should be basically the cable that we restored. It was pulled out on both sides. This is for how we're setting your control console up, this is probably a longer cable set than we technically need for you, so we might swap some B and Cs out later.
Okay.
But we'll get stuff integrated. Okay, so I'm going to have you start with your T. Okay. So this is your video T. So this is how we're going to get video from your microscope. Okay.
Okay.
So that's going to go into NA7.
Okay. So on this end.
That's JC2.
Oh,
so
okay.
NA7 is the one that's down here. And then remember, watch out for inside here.
Yeah.
So let's move that away further. So NA7 is down here.
Oh,
so this is your
yes.
This is your detector control area, right?
Okay. Gotcha.
Yeah, so pull out NA7 there. And let me get the other half that's going to go also onto NA7.
Cool.
So here is, oh, that's Y. Nope, I want detector. I should have to, just making sure detector is actually labeled on both ends. It is.
Tragic.
It's not going to be a problem. I'm just going to pull the detector out of this. I'm just going to unloop the whole bundle.
Cool.
It was, I had it bundled so that I could pull it apart, and I made a mistake, and now it's not, so that's fine.
Tragic.
Yeah. Yeah, these are a lot longer than we need for your setup, but I've got other cables, but we'll start with these, and then we can swap out to whatever length you actually end up needing.
Sweet. Yeah, I think I have some extra BNCs kicking around too.
Yeah. Jeezless. Man, pull one cable out wrong from a nicely coiled set, and
right?
You regret everything. Okay. Glad I did this before I made one end a lot harder to deal with. Okay, here is the other end of your detector cable.
Okay.
So you want to show the camera the T you just put in?
Yeah, so we got T here coming from NA7 to this three-way splitter. One of the tie-offs going here to the detector line.
Cool.
Beautiful. I love the labels. Those are new labels you ordered?
No, not even. These are.
wow.
I carry the orange labels with me.
Nice.
I got you pipe color labels for all your new plumbing.
Very beautiful.
But orange and black, that's I got a lot of orange and black with me.
Those are like your colors, right?
Yes. Okay, so go ahead and put that into NA7.
Oh, like this whole thing here?
The T, yeah.
Oh, okay. I see. So we're splitting
And
NA7.
watch up behind you. You're awfully.
Oh yeah.
Close.
Sorry. Thank you. Yeah, I haven't normally worked on this thing while it's on like
Well,
this. So.
partially, yeah.
Okay, we're in there.
Excellent. So that is that's the detector and done. So that was hard.
Yeah.
Not.
Hardest thing I've ever done on this scope.
Okay. So this is our JA7 interface right here.
Okay.
So
At
before
least know
you
where
do
that
that,
is.
let's get the other cables into it.
Okay.
So this cable, oh no, that's the power cable. I need to get you a different M8 cable, I think. Unless I have it right here, which I thought I did. Nope, I don't have the M8 in that bundle. Okay. Let me give you the X and Ys. These are more appropriately lengthed. So go ahead and put the X and Ys into the X and Ys on there.
All right. Here. Show the camera here. Oh, thank you.
And let me get an M8 out.
What does the blue, brown, and black wire thing go to?
So that is the cable that I'm retrieving for you right now.
I see.
And that is how Open Beam Interface flips the relay that tells the microscope to use the external scan signals instead of the internal scan
Okay, yeah, that was
signals.
the relay that was broken on my other ScanGen board.
So it's not, well, yeah, no, that is the relay. Yeah, that's the relay. What we're doing here is, so that cable flips. You see the silver relay that's on this board?
Yeah.
It flips that relay.
Okay.
Now that relay doesn't actually have scan signals on it. That relay connects 2 pins together on JA7,
Okay,
and those
sure.
2 pins
Pull down that
flip
relay.
the relay
Okay.
inside the microscope. Yeah, exactly.
Sure.
So that's shorter than we want. Let me get out this one. That should be the right length. Yeah, cool. Let me just cut the elastics off this for you.
Okay.
Okay, so the way we structured so this is an M8 connector because it's a
Okay.
metric 8mm thread.
Oh, okay. Nice.
So we're technically only using 1 pin of it right now.
Okay.
And ground.
Oh, it goes on nicely.
Yep, and then we keep the cables that have voltage potential on them.
Yeah.
When not plugged in, that's the female side. So that's why the side you're
Okay.
holding in your right hand was male pins,
I see.
because that part doesn't have potential on it, but this one does.
Is it normal for the threads to kind of just get like stuck there? Because I can't get that any farther.
Yeah, no, it's
Oh, okay.
it's in.
It's like a press fitting. Okay.
Oh, it's yeah. Once you have, it's like, no, yeah, you're in. It's like
Okay.
you're fully tensioning it on
Okay,
it. So
cool,
that's good. Okay, so you got all the cables in that. So that goes into
JA2.
JA2 now. Yep,
Okay.
the infamous JA2.
Yes.
Here, let me go handheld for a second.
Yeah,
here.
that's a good
And then
idea.
remember, we got the box open behind you.
Yeah, I'm being mindful of that.
There
There
How
it
do I
is.
get this camera off? Oh, there's a button.
Yes, there is.
I think there's a button. There's a button that does the
You got
thing.
it. All right.
Yes.
Could you lift your foot for just a second?
Yep.
Perfect. All
Let me,
right.
I want to get the.
Yeah, we gotta get that.
Okay, I'm not set up to get that yet because I got
Okay,
cables in the way.
Here, I'll help you out. Because it's in manual focus too.
It's focused. It's just I'm not.
Okay.
There we go.
Beautiful.
Nah.
Beautiful. This is gonna be the best footage of JA2 getting plugged in on YouTube. Boom. It's in.
You got both of them latched? Cool.
Yep.
So that is our external interface connected. Got a boop. Cool. Sorry.
No, you're good. Okay. Anything else we need, or is that it?
That's it.
What the
Oh,
fuck?
sorry about that.
You're good.
We need power.
So true.
And so power.
I saw there's a barrel jack on here, or what is? Oh, it's another one of those.
It's another. So that's actually. So that's what's going to connect to the one that we have. That we just connected to.
Oh, I
JA2,
see.
But this one is where is power. Okay.
Okay.
Now to kind of avoid like ground loop issues, we try to get power from inside of the microscope itself,
Okay.
which we have the cable to do.
That makes sense.
Yeah. So that is.
I've never experienced ground loop issues in this setup in my recording studio all the time. I hate.
This cable here. So this cable plugs into open beam interface there. And then these 4 pins we use the accessory power supply. That's like kind of built for stuff like this.
Okay. Is that
That.
Is that this thing right here?
That is
Okay,
that
nice.
terminal strip right there. So let me get the. I need to label your wires on that one, but I have a good photo of what's going on here. So I'm just going to grab that real quick. The other way we could plug that into OpenBeam. All the power supplies are labeled really well in OpenBeam, so we could just look at what is going on there. Okay, so we got our Phillips driver, cool. So we are tapping, if I got off the cover on it, that would have been slightly easier.
Here, I can show what's going on back here.
So there's our accessory power supply that we're tapping into here.
Okay, so let's see. I think I'm okay. I think I did match the colors in this one. I made this one, or I tried to. I got as close as I could, I think, on this.
Sweet.
Yep. Okay, so our green one here is going to go to our 0 volt rail there. Okay, so that's our 0.
Okay.
And then we got dark brown, and we'll call this one orange, but it looks also kind of a light brown. So then brown goes to 5. Yellow goes to -20, and orange goes to +20 there.
Okay. Yeah, first thing I'll do tomorrow is clean out the front
Yeah.
there. I just totally forgot it was dirty.
It's
or
when
I
the
would've
panels are
done it.
on, you know.
Yep.
Okay, so we'll loosen up what we're working with here. So that's going to be our ground. I think we'll bring this in like this.
Yeah, good call.
This isn't technically ground, this is 0 volts, and there is a difference.
Okay.
And then we're doing brown to +5. And we're doing yellow to -20. We're doing orange to +20. Everything's torqued appropriately. You can't break you can break these screws off, by the way, if you over torque them.
Good to know.
Make sure that goes behind the panel. There we go. That is integrated with your power supply.
Sweet. Okay, well that's installed then, right?
Pretty much. We are going to test the pins to make sure we got everything correct, and we're going to measure the voltage on them.
Okay.
Just as a
Yeah, that makes sense.
triple verify. You know, if you're doing screw terminals, not necessarily a mistake-proof device, but this just kind of works out really well in this platform to be integrating here.
Oh, sorry, I didn't realize you're coming back this way. I guess that makes sense.
So we got a detector integrated in the
Careful, you got a
K7.
DNC around your foot.
We got JA2 integrated. So that should basically be everything we got to do in the console now. So we can go ahead and we'll kind of bring these out. Oh, we got wrapped around the HV cable, so let's pull that out now. Yeah, we need to put a shorter detector cable on. I have one. It's just I didn't have it labeled, so I went with one that was labeled. Okay, so your high voltage cable wasn't quite routed correctly. I'm just going to tuck that up here nicely so that kind of strain releases it a little bit better. And we ended up with this over top of the high voltage cable, which you don't really want, so we're going to route that underneath the high voltage cable. Yeah, always thinking about cabling topology when I'm working inside of here. Keep things nice and neat. Or maybe not keep them neat, because I don't think they are neat right now, but at least trend in the right direction.
Sure.
Does that blue one go to?
Up to the Keithley.
Okay. Okay, I'm not going to mess with that right now. I'm just going to leave that where it's at. Okay, so we got our scan enable, and then we got our detector, and it's wrapped around me a little bit, and we got our power.
Well, I made that worse.
So that's our open beam interface cable set.
Beautiful. Sweet.
Just throwing a zip tie on it, just gonna keep it together for now.
Sweet, I'm gonna get this camera back on this side. Just gotta get it out from around all these cables. There we go.
So a question for you, Maria. Is the timer on Monochroma's flashlight still running, or? So I don't think we've technically found that yet.
I'm gonna take a quick restroom break. I'll be right back.
No problem.
Sorry if that was loud. Everybody, we need to do that.
How's everybody doing? Let's see here. What are we down right now? We're down a laptop. That. There we go. We're back up a laptop. I'll just clean some stuff up here. Well, that was fun with the two issues we're working. Figuring out the chart, or the figuring out the collector one, I enjoyed that. It's like there's kind of a, to a degree, there's a kind of like a finite-ish supply of like microscope problems to solve. 'Cause like once you solve them, they're solved, right? And they go away. It's like, it's only like an unknown for so long. So we'll mount up the open beam interface a little bit, well, at all. Right now we're just going to kind of sit it on the control console. Oh, we left the mouse here. We don't need the mouse anymore.
So true.
And we're using a
don't need this either.
MacBook tonight, so we don't need a mouse pad either.
So true. Here, I can take that mouse. I'll throw it in my old computer junk pile.
It's gotta be a little bit satisfying.
It really is. Oh yeah, did I tell you about our cell cut stage? I forget.
No.
We have a cell cut stage on the confocal, so we can cut out like a single nucleus from a cell.
That is awesome.
It's pretty sick.
The confocal that they have here, amazing microscope.
Yeah, it's really cool.
Have not gotten to play with it yet. Definitely want to.
I need to do a stream on just that sometime.
Okay, so we got our cabling kind of cleaned up a bit. We can go ahead and close up our control console now.
Oh, my phone's like 2 minutes behind. That checks out.
Okay, so now we're gonna go OPE on. Are you ready?
Yeah.
Okay, OPE on. Can you give us a key turn?
Boom.
Cool. So I have not plugged Open Beam interface into power yet. We are doing our voltage check. So if I remember correctly, the 0 volts I think is actually grounded right now because something else is using it. No, 0 volts is ungrounded, so I do need to, I need my other pokey probe to do this. The very fine pokey probe, this one.
Oh, nice.
Oh, we lost the pokey bit.
Oh, shit. That's not good.
That's not good.
We were using it down here, right?
Yeah. Well, we will want to find that because I would like it to have it, but I don't need it right now, so.
Okay. We'll, worst case scenario, I'll sweep the floor with a magnet tomorrow.
Sounds good.
Yeah, I'm not seeing it with a flashlight. But this floor is also so horrible and so hard to find things on, so.
Okay, you're gonna need this in a second, maybe.
Okay.
Probably not.
I keep not even realizing this is on because I'm just so used to associating it with a really loud noise.
Yeah, that water chiller in here really, really messed with you.
Yeah, it did. See, this is, I actually watched the stream like a month ago where you set up OBI on another 6400, so.
Yeah.
I wasn't able to watch that whole stream, but I watched like at least the part where you did that.
So you're a bit familiar with the process then.
Yeah, a little bit.
Okay.
And I had absolutely no instruction on how to hook up the 4-pi, so that was a lot of trial and error that I've mostly forgotten at this point, but.
So our bottom right pin is our 0 volt, which I think I can touch. I might need to put something into that to be able to touch it with this probe.
Just like any piece of metal.
I'm gonna check the vicinity of where I think the pokey thing is. Actually, it's possible the pokey thing is on the other place I was probing, so I'm gonna go check over there real quick.
Okay.
Ah, it is.
Ah.
This makes life easier.
This is the first time our air compressor's run since we.
I think so.
Okay, is that a good rate
That's decent.
for having an air table, I guess?
For having the air table on it, yeah.
How long does like a On OBI, first of all, when you're doing like a 16K scan, what's your max like zoom with that kind of a scan?
What do you mean max zoom?
Or I guess like what's... I know you said these things should be able to get to like 100,000x, like...
Oh, like a good 1024 image at 100,000?
Yeah. So like what's a good image at 16,000? Like what's the farthest you can zoom in for...
I mean, you could probably like take meaningful like 16K images. I'm just...
Yeah, just a spitball's fine.
40,000?
Okay, that's still pretty awesome.
Because like, it's just, you can digitally zoom in really far from there.
Sure. Yeah, I've taken like 3 4K images with this thing that didn't completely, that like actually scanned correctly with the 4Pi, so.
Okay, so we're going from 0 to 5 volts. Okay, got 5.27, cool. And then we'll check between our 15 volt rails. Between our 15 volt or 20 volt rails, we got 20 volts, so that's our 20 volt rails.
Okay.
And then I got my red is in my positive, so that's what we want to see. Cool.
Sweet.
Okay.
Good to go.
Yes, and so Open Beam interface is hot pluggable. So you can just
plug it in right now?
Yeah.
Sweet.
And then I got a different cable for you to not have those just random pins there.
Okay.
But let's just plug it in and
yeah, sure.
Yeah.
That's fine.
Okay. So we're gonna kind of have this down here.
Okay. Right to this side right here?
That's your power. Wait, let's get the, there we go.
I can unplug it though, right? Because it's hot swap.
Yeah.
For dramatic effect, so. Pretend you guys didn't just see that. Whoa. That's so cool.
There we go.
Sweet.
So here is a compromise that was made with the design. The detector output, or the detector cable, and the scan cables are both the same types of BNCs. And that is because BNC cables are usually a specific type, and so for maximum flexibility, things are done that way.
Sure.
Now, that does mean that you can accidentally plug the wrong thing to the wrong thing.
Okay.
It is very important that we do not plug a detector cable into a scan port, because then you have two things trying to fight each other.
Okay.
We don't want that.
So cable labeling very important in this
Cable
context.
labeling is very important.
Okay.
So you got 4 cables here, and one very long one.
Hey, I think I know which one that is. Detector, right?
Yep.
Should I just do these 3 first?
You can go for it, yeah.
In any order? Does the
That's
order
correct.
matter? Okay, cool.
So you see where the labels are?
Yeah. Why to why?
Why to why?
Easy enough. Okay. Oh, I pressed that button by accident.
That's fine.
Okay. X to X, I'm assuming.
That's the reset button for Glasgow. We don't even have USB plugged into Glasgow yet, so it's
okay,
like...
so it's doing nothing right
Yeah.
now? Okay.
If you did press that while the software is running, you're just going to have to relaunch the server.
Okay, gotcha. Okay, and then this is our detector cable.
Is it labeled detector?
It is indeed labeled detector. So we will put it on the spot that says detector. It can't get any more foolproof than this.
Well, I mean, it can.
Yeah, it definitely could. Not tonight, though. And then
This is our last cable. What is this one again?
That's the scan enable, and it's not labeled right now because it's on that one.
Oh, okay, gotcha.
I think those M8s are pretty satisfying.
Yeah, they're really nice. I've
So
never used that.
you're twisting both of them.
Oh shit, I didn't realize that.
You just gotta hold. They both spin.
Gotcha.
So you're loosen it.
Oh fuck. Oh.
And then you gotta.
Okay.
Just the ferrules opposite directions.
Yeah. Did I fuck this up though?
Nope, not
okay.
at all.
Okay.
It just won't actually tighten unless you keep one of them still.
I see that. Okay.
Okay. So that's everything for the
that wants to
microscope.
like slide off. We should.
Yeah, we can.
Fix that. Oh yeah, just run it around the film holder. We don't want to short that stuff, I'm assuming.
Yeah.
Cool.
Cool. So that is gonna. I think we're gonna mount that.
Yeah, we'll get that
here.
looking nicer.
Yeah. But for now, we have one cable left to connect. Ta-da!
USB. All right. So USB, I'm assuming, goes into the USB port.
Yep.
All right. Fancy.
And if you want to come put that into the computer.
Sure.
Ta-da! Okay. So now
Yay.
We are going to get the software going.
Sweet. Do we want to make the computer window bigger at this point?
Yeah, I'll work on that.
Okay.
So at the top of the page is a link to the instructions.
Oh, perfect. I can do this.
So you did the git clone?
Yes, I need to install PDM. Well, you probably already have it on this computer. don't you?
If it was on a different user.
Okay, let's see. I don't know PDM. Let's just see if it does anything. A big repo.
Yeah, that could be cleaned up some.
What is it called? PDM? No. Okay. Wait, what version is my Python?
The PDM will take care of that.
Okay, cool. Excuse me?
If you scroll up.
Oh, maybe I need to install Python first.
You can alternatively you can download the standalone binary file.
Ah.
That's the source.
Oh, shoot. I don't see a built file in there. Maybe this one has one. There we go.
It's x86 Apple Darwin.
Yeah.
Actually, I think we're probably gonna actually do this via. Can you go back? Cause I think we're gonna want to do this via homebrew.
Oh, just do like brew install PDM.
Yeah.
Is brew on here?
Nope. I mean,
Okay.
it will be.
No, it is. Oh. What's your Oh, it's just the password for this user, right?
Should be.
Is
I
this
think.
user sudoed? Oh, we gotta
Okay.
sudo them real quick.
Yeah.
Yeah.
No looking.
Yep.
Wait, did that just leak to the stream? Okay.
It's just this computer's password, so.
Oh, okay, cool. Spirit saw it. You're cooked.
Yeah, if you have local access to this device.
Why is the MacBook stream yellow? What? What do you mean? Oh, it's probably got flux on. Yeah, there you go. On yellowed. Spirit already hacked it. You were too late.
I did think about making this an administrator. I was like, that would make this easier. Let's see here.
You might have to. Were you able to add it to the sudoers file, or
Not from this user. I can add it from the other user.
can you su into your user from there?
I could, or I could just do it the easier way.
Yeah, fair enough.
Close lock, then we'll go there, and then we'll go. And then we'll go there. Come on. Come on. Users and groups, OBI, and allow this one to administer.
Yay. Oh, we had a camera die.
Restart.
I think your camera died again. Do you have another battery?
Yeah, I do.
Where's it at?
It's on the desk right there.
In here or out there?
Right there. Underneath the schematics, probably.
Oh, okay. Oh, I see it.
I think I'm just waiting for it to shut down right now.
Cool.
I think. It's really thinking about it. Okay, it's thinking about shutting down. It'll get there.
Sweet. Oh man, you can actually open your battery door with the
I know,
telephone, so
right?
That's very nice.
I was like so good.
Oh, it almost worked.
Okay.
So
yeah,
sad.
Not quite.
How
So
do
close,
I-
so far.
How do I loosen this? Oh, just this thing?
Yeah, and then you have to push like the release.
Oh, I see. Just I thought I saw.
Isn't that fun?
Oh yeah.
You're not quite pushing the release.
This
But
release?
hold
here?
on to the camera while you do it. I think other way.
Oh, this.
No, okay, you guys are right. But you gotta loosen this more.
Oh, okay. Oh, that was my
There you
problem.
go.
Sorry. I haven't used one of these fancy
Hey,
tripods.
it's
Mine
finally
are all
turned
too
off.
cheap. Okay, there we go. Okay, that's back. Which is this one?
Yeah, it's back. We're just waiting for this to reboot.
Cool. Which camera is this one? This is the OBI. What?
It's coming back.
Well, the yours is back. I don't know.
No,
which...
it's coming back. There we go.
Oh, I forgot that you switched OBI to the main screen. That's what I was confused about. It's late, okay.
Okay, so now we can pseudo this.
Sweet. Just the user password now.
Yep.
Sweet. Sweet. Cool.
Cool.
Well, that'll make things easier.
Does the color look more normal now, Spirit?
I think it's gotta. Okay, brew is installed. So
Okay,
now let's
so
try.
that should just be brew install PDM, right?
I would guess so. Hello. Oh. Got to restart the terminal to get into the context. Yep, it looks like it's gonna work.
Cool. I don't know why PDM doesn't like maintain official ARM builds.
Yeah, it's weird. Okay, so let me close these. So now that we are, sweet.
Still not going to show because the no, PDM's going to take care of it.
Okay, okay. So PDM's got it handled.
Yeah.
Probably didn't need to put it in a double folder, but
yeah.
I'll move it out.
So this takes care of a lot of Python issues because PDM is handling this and creating a VM for
sweet.
what we're doing.
Is PDM just like a virtual environment like manager or like?
It kind of does a little bit of that, but it's not like VM.
Okay.
It also does dependencies.
Okay.
So it's taking care of all of that for us too. So Glasgow is the biggest one because Glasgow is what has the whole FPGA toolchain in it.
Sure. So are there people that use Glasgow without OBI?
Oh yeah, yeah.
Okay, interesting. What are some of the bigger applications for that?
Most people use Glasgow as like a tool, like a multi-tool.
Okay.
Like they branch their project, hack on it, figure out what's going on, and then move on to the next thing.
Okay.
Electron microscopy is just like, yeah, this thing, we can just like put one of these in everything and it's fine.
Okay.
Because, yeah.
Okay. Well, it should be updated already.
Yep.
So we should be good to go.
So the one thing that's not good to go is the microscope toml file.
Oh, I remember reading about that or watching that in your stream.
Yeah. So there's example toml files in software.
Oh, it was in software.
Yeah. So the toml file is a git ignore because we don't want we never want your toml file to be replaced by an update.
Okay, so is it pyproject.toml? Is that the
No,
template?
no. It's go to configs.
Oh, my folders are usually different colors, so I'm not used to.
And then copy the JEOL 840 63 6400 to the top level, and then rename it microscope.toml.
Okay.
Okay, so now you're good to go.
Oh, do I have to modify this at all?
No.
Or is it, oh, it's already set up for the
Yeah,
6400. Okay, cool.
I mean, you did. Oh yeah, you didn't save it.
Yeah,
Okay, so yeah. So PDM run launch.
Inside the software folder?
Yep.
Oh my god, it's so exciting.
So run server.
It welcomed me.
And show logs. Allow. We figured out what that was, but yeah, that's something kind of funny. So it's building the bit stream right now for the FPGA.
Okay.
It only has to do that whenever the source for the FPGA, whenever the gateway is like modified, because it's checking against the cache. So while installing OpenBeam interface, you installed an entire FPGA toolchain, like without like trying or thinking about it very hard.
That's, your install works great.
And then so now run the GUI and start scanning. Start live scan.
Wow. That's beautiful.
So you can make that, you can double click the bar at the top. Oh, and we're gonna find one GUI bug here when you double click, go up.
Oh.
Yeah.
Oh, sure.
So bring the side of the window in a little bit. Keep going until you can see the tops and bottoms. Yeah, so, yeah, yep.
Sweet.
And then we're gonna turn the brightness on the monitor down because you're seeing what we're scanning. I have
wow.
I have a jumper on the JA2 board that we were using to blank this monitor.
Okay.
I'm leaving that on so we can see what the scan's doing.
Sure.
So let's go down to set it to like 5 kV.
Okay. Now, am I still gonna find saturation on that monitor?
No.
Oh, okay. Because can it do line profile and everything?
We don't really need. It has a histogram that works really well.
Okay.
So yeah, make sure your filament current's down. Go ahead and turn it on. PF2.
What? Oh, yeah. Aperture.
Let's go to spot size is high enough. Okay, go ahead and find detector snow.
Okay. Oh, there's some already.
Yeah. Okay, cool. So you got detector snow. So turn your brightness down. So you see the histogram on the left, how that works?
Oh yeah.
Yeah.
That's really nice. Ooh, I like your histogram.
So that's what you're gonna saturate with.
Okay.
So go ahead and start turning up your beam current.
Interesting. Oh wow. Yeah, this almost feels like it's even more responsive than, well, it's obviously more responsive than the CRT. Okay, so I'm looking for my false peak here. I have to retrain my brain for the shapes I'm looking for.
There's not a memory leak from the log span. It's fine. It's like gated, and that can be turned off. Yeah. What? So just keep. You can keep going.
Okay. I'm so used to the line profile. I'm trying to retrain my brain on what to look for now. Whoops. Okay, I see. Oh, I love that the contrast and brightness are different scales on there. It's so hard for me to tell if I'm saturated now because I got to relearn.
So this whole thing's going to move up and then back down and then up
Oh,
again.
so I was looking for like a change this way.
So this is a vertical, so that's 0 brightness, that's 256.
Okay. Okay, here. Sorry. I'm just trying to comprehend what's going on.
Yeah, you like I frequently the frame rendering loads down is by far more low than the printing, and we are more than performant enough to be doing the scanning that we're doing. So that was you see how it's going darker?
Yeah.
So that's your false.
Okay.
Now we're going up again.
And we're plateaued, so that's saturation. Well, let me hit right at the point. Okay, that's the direct point of the
There you
plateau.
go.
Okay, nice. Are
So
we looking at a feature right now? Or?
Yeah. So you're scanning very fast, so you're seeing some like scan hysteresis because you're at 5. So remember when we were at 512?
Oh yeah, Jesus.
So this
That's
is
so funny.
like zoom out some.
Oh wow. Yeah, that's so fast. There's some. Is that like lensing or what's
So that's
that?
the scan distortion.
Okay.
Because of the rescan because we're scanning like faster than the scan code is going to really high. So if you zoom out some more, and then do the set your like dwell time to like 2. You see how it gets smaller now that you're scanning slower?
Oh yeah.
And then hit fast one more time. So you're interlace scanning right now. Actually, hit zoom in some. Yeah, zoom in so you can get our PF2 menu back here, or menu back there on that one. Well, yeah. But you're in interlace, so I don't think it's working while we're interlaced.
Oh. That's not changing anything. It's like that panel's locked out.
Your computer's frozen.
Oh, I'll reset it.
It's gonna. You should turn the filament down before you do that.
Good idea.
Oh, I bumped the computer with my foot. Is what happened.
Oh. Okay. Should I turn voltage off too, or just?
Yeah.
Okay.
Yeah, now reset.
There's usually a relay that clicks when I do that. Oh, the computer's probably.
Cool.
Okay, cool.
Okay, bring it back. You're gonna be a different spot size probably. No, remember. Cool. Okay.
Oh wait, I don't have detector snow.
Well, but the settings are the same as. Well,
Oh, yeah, fair enough.
Probably the same.
Fair enough.
It's good to have detectors now.
Whoops. Yeah, there's false peak. Okay. Right there.
Cool. So if you you can do like dwell 4, and you see what the distortion left does.
Oh yeah.
So every time you increase your dwell, you also average more pixels, so you get like a clearer picture.
I see. Interesting. Okay. That makes sense.
Yeah. So yeah, try focusing, stigmating, zooming, and all that.
Yeah, sure. I feel like I need a big ass monitor in here now.
Right.
Okay.
Yeah, we can do this.
Oh yeah, that is nice. Okay.
And the MacBook can move over quite a bit too if you want.
That's true. I'm happy with this
Yeah.
right now. All right, let me just get in. One thing is like I'm so used to seeing the magnification here.
So scan 2 disables the interlacing.
Okay.
So if you go to EOS page 2, and then go scan mode or speed 2. So TV has interlacing. See how the image is like jumping up and down a little bit? That's the interlacing circuit. But if you use scan 10, that applies. You see how it put a capacitor on the video signal.
Oh, okay.
So scan 2 has no interlacing and no capacitor in the video signal.
Okay, interesting. Well, why did it freeze?
I don't know.
Okay, so is there a way to get scale info on this so like it changes as you zoom?
Yes, with RS-232 connection.
Okay, sweet. I can set that up later then.
Yeah. So focus and stigmate.
Okay, yeah. Oh, that's way out.
So yeah, you're in. And then you can also drop an ROI. So click ROI scan. And then you can just like drag the ROI around.
That's really sick, actually. Okay, Stig is immensely out.
And then so at the end of a frame, it is holding the beam
Oh
there.
shit, that's not good.
Well, yeah, it's not quite bright enough to cause a problem.
Okay. Okay. Sorry, it's like kind of relearning this thing a little bit. It's initially a little bit harder for me to tell what's going on, I feel like, but just because I'm so used to looking at
if
the
you zoom in
CRT.
some, you'll have a way easier time. You're just there's
Oh, totally.
Yeah.
Totally.
You're not focused. More. Keep going. We'll take it the other way.
Oh.
You were so far away from fully
I
focused.
see.
Yeah.
So like in between these two
Yeah,
would be
exactly.
fully focused, right? And you
Yeah,
bring the
yeah.
stigs in to match. Okay, yeah, we're getting somewhere now. I wanted to go to some of these brighter ones.
You're at 40,000 right now.
Oh shit, that's pretty good. We're only at 5 kilovolt too. Wow.
Yeah.
And our collector's broken.
Yeah. I think is our collector on or off right now? It's on.
Oh, it's on. Okay. So we're not experiencing the issue right now.
Yeah.
It is intermittent, like I said.
Yeah.
So.
So we're only at 5 kV, so I'm pretty happy with that for 5.
Yeah, no kidding. What can I try a slower scan?
Yeah, yeah. So stop the live, and then select what resolution you want, or just ship it.
Yeah, I'm just gonna try it.
And you can 2-finger zoom on it, or just up.
Ooh, okay. So you can zoom into the buffer on here too.
Yep.
That's very nice. I'm used to it, so it's not like new
Yeah.
for me.
Yeah,
But
yeah.
it is nice. I'm glad I didn't lose it. Yeah, this is already like a billion times better than 4Pi. I would have had. Well, there's still maybe a little flaggy, maybe.
It's hard to tell with the if we increase the kV or decrease spot size or
Okay.
stigmate the beam more, we can look into
Sure.
if we're getting flagging or not.
Okay.
But we've got a better tool now to like figure out what our noise is.
Yeah,
right?
no kidding.
Yeah.
Okay, cool. I want to try a. I just want to try a crazy high resolution.
Let's zoom out some.
Okay.
So if we do like we'll do 3,000.
Okay, sweet.
Or we'll do 2,000.
Because that'll give us a nice
Yeah,
high
yeah, yeah.
resolution. All right. How fast does a 16K image
You can
acquire?
see.
I guess you're right. I can see. That literally acquires as fast as a 4K image would acquire on my old system. It would take me
Well,
about.
you're at dwell 8.
That's
so,
true.
So one dwell is 124 nanoseconds. So the number of dwells you're at is.
It's still looking really good. It's looking like not distorted, which I love. These are some of the cleanest scans I've gotten out of the system already. Damn. The pixel that I'm so not used to being able to zoom in that far before I see individual pixels. That's fucking insane. I'm sorry. I don't mean to be cussing all over your stream.
I love it.
Okay. Yeah, maybe just a little flat. It's hard to say. We're gonna have to,
We need to. We're at the limited resolution right now.
Yeah.
Or of what we have the beam adjusted for. So we're only at 5 kV too. So flagging's gonna be worse at 5 if it is for magnetic field.
Okay. Man. Yeah, this is so cool. I love like it. It has like almost like a nice grain to it now that I didn't have before.
So this is the signal chain was carefully designed for this. So we've got the RC constants right. So we don't have aliasing issues.
Sure.
It's doing true averaging.
Yeah, like the averaging looks great.
Yeah. So it behaves. We're limited by like the actual noise of the system. We're not.
Sure.
You're not getting into like weird 4Pi issues.
Oh my gosh.
And
This
that's
is
it.
so good.
Like, yeah, this is quantized noise. This is like the noises from individual packets of information. If we scan slower, there would be less of it.
That's awesome. Do you have measuring tools on here yet? Could I measure this?
Sort of, but not really.
Okay.
They're like so.
I might be able to add them. I don't know.
There is this whole thing. So we can drop a. Where is it? Put it somewhere. Yeah. So they are like halfway there, we'll say.
Okay. Sweet. Yeah, I want to.
One thing that 4Pi had that I want to be able to replicate is I was able to take its raw files and upload them to a tool I built, and then like people that send us samples, I basically just send them the raw file, and they can then go in and crop and measure, and it imports the scaling per pixel from 4Pi. So but I feel like I could pretty easily build some of that with this now too.
Yeah. There is some of the backend for the metadata handling that is using very standard stuff, like metadata compatible with like ImageJ, like just out of the box.
Okay.
And there is other tools. I'm trying to remember the name of a particular one that I am thinking of. I know the guy from LinkedIn. It's a pretty cool tool. There's a lot of what you're describing is already built and already uses kind of like standard metadata formats.
Okay.
So if we stick with the standard metadata formats, we can just like...
Perfect.
Yeah.
Yeah, I think my next step, like after you leave next week, I'm probably going to try to get the... I'd really love to be able to get the magnification info on these two.
Yeah, pulling it straight from the C report is very, very convenient.
Sweet. Is that line supposed to be parked there like that?
It's not parked. It's scanning at the same speed that is.
Yeah, that makes a lot of sense. That's crazy. That is a slow scan.
So this is a 1/4 gigabyte file, because that is a uncompressed.
That makes sense.
16K by 16K 8-bit TIFF.
Sweet.
And that's just how big an uncompressed 16K by 16K 8-bit TIFF is.
You could print a wallpaper out of this. I mean,
I
wouldn't.
Yeah, our focus might have drifted because we turned this thing on and then took a big picture, so it looks like our focus is drifting as time goes going on.
What causes that?
We gave the microscope absolutely no time to warm up.
Oh, I see. How long is a good warm-up time?
I don't know for your system. We have not characterized your system stability or noise.
Okay.
I'm just observing that focus has drifted. So
Sure.
it saved it automatically. Even if you aborted the scan halfway through, it would have still saved it automatically.
That's
awesome. You want to do a light scan real quick?
Yeah.
We can go somewhere else on the sample.
Damn.
This is all of this is like test stuff from Fib.
Sure.
These are platinum deposition tests that were done.
Oh, cool.
So these were lines that were deposited with different parameters, and then the end of it was sectioned or was cut in half so that we could see how thick it was. But I got some other samples on here. What's this one? This is the, I think that one's the one that we use for like GIS needle touch off, random calibration grid. Oh, here's a,
This looks so good.
this is a ruler that had a GIS from a Fib throw up on it, basically. So there's the ruler.
What are the scale bars, or what's the scale on that?
It tells you.
Whoa, just changed program.
Yeah.
It looks so much better.
So the overall thing is 1 millimeter.
Okay.
So that whole thing is 1 millimeter.
Gotcha.
Is it the passivated chip? Yeah, this is a passivation layer, so this is like polyamide or something. So this is, we're charging a lot.
Yeah, we are. The lights just turned on.
That's another insulator that's used for testing the milling on insulators.
Okay.
Or insulator etched. This is another sample that the GIS leaked onto. And that's
What are all the little like specks of shit on there?
That's all that thing that
just
leaked, and
the
then
GIS.
yeah.
Gotcha.
is our Faraday cup that has been just absolutely blasted by a fib.
Huh.
Because it's being used to measure fib beam currents constantly.
I see.
So that'll be kind of fun to zoom in on.
Whoa, yeah, you can see the actual milling.
Yeah.
Stig is a little out, I think, yeah.
Yeah.
Damn, what magnification are we at right now?
8500.
Okay.
We're at a pretty high pro.
Like for 5 kV, this is really good. Like
We're
this
at-
is.
Yeah, we're at 10 on our condenser. Oh, it's not just backlash. There's other weird things going on with that.
Wait, 10 on what?
10 on our spot size is 10.
Oh, okay.
So this is actually NTSC.
Oh, okay.
So you can capture this on the computer too.
Oh, okay,
With
gotcha.
like a USB NTSC device.
Okay, sweet. Oh yeah, I knew that because I had it teed off to an old monitor that I was using to duplicate it. Well, that was how the guy was doing it that I got it from. But
you just made it work correctly. So that's our, just to show you our like limitation from spot size. So this is spot 9, and that is spot 15. So set our dwell time to like 8.
So you have a higher signal noise with a
Yeah, or
smaller
go
spot.
16. And you can go custom too, and you can go like higher. So
okay,
it's
cool.
we're slower now, right? But our beam is very small now.
Yeah.
So that's 20,000 at, and we can zoom in and let's do some shift. So this is 50,000 right now.
damn. Yeah, this is better than I've ever seen at 5 kilovolts out of this scope.
So a lot of our flagging is definitely from your chiller because we're not seeing
Yeah.
anything.
No kidding.
So the chiller being moved is a big part of what has given us a substantial
Yeah,
resolution improvement.
that's great.
And then do a 1K photo, set it for a 1K photo, but then set your dwell time to like 64. You can do a much higher dwell too. So I'm going to zoom out a little bit. I'm going to zoom out to 35, and then set your dwell, do custom, and then do like, I don't know. Yeah, 128 would be fine.
Looks like a little face. Is there some flagging there, maybe?
Maybe.
Like these, like.
Yeah, that's possible.
It still looks
it doesn't
great.
quite look like what I would expect flagging to look like.
Okay.
Not at least not consistent flagging. That might be flagging from vibrations and not 60 hertz.
Okay, that would make sense to me.
That's just, it could be 60 hertz, but that's not immediately what I would like.
They're pretty
recognize
big
as 60 hertz. Yeah,
oscillations.
yeah.
That's
And
awesome.
that was a really, really slow scan too.
Sure. That's so cool.
Go back to live view if you want. Let's increase our spot size a little bit. You want to do a faster scan?
Yeah.
And we'll just increase your spot size a little bit more just to have a nice crisp picture. And then we're going to drop down our, that's fine. We'll drop down our working distance. So you can like watch these things like in really like real time, like really easily.
That's awesome. So we're at 8 now, or? Oh no, we never went all the way to, oh, you're at 48, I see.
Yeah, so we're at 48 now, but like, so the reason I'm going down this low.
Oh, oh.
So watch, let's look how much fun tilting is now.
Oh, wow. That's pretty crazy.
So let's get our tilt axis aligned with our, yeah, and then we'll do a little bit of sub Z to set our eccentric height better.
Yeah, I've barely used the tilt controls on this, honestly. So when you're at 48, you can pretty much tilt all the way, right?
Yep.
The college interns are they're gonna fucking love this. They're like 3 people have trained how to use this scope. I've had to be like, yeah, and you have to do this thing when this happens, and you have to do this thing when this happens, and maybe you'll get a good image out of it after like 3 hours.
A little bit different now.
Yeah.
So that's sample charging effects.
Okay, yeah, sure.
Big time sample charging effects.
Yeah.
Maria, we are looking at a, oh, welcome back to the stream, Maria. You came back at a great time. We are looking at a FEI calibration sample. So here's where they just like integrate, so that's like the side of the carbon that they deposit all the gold on. And then actually, we've got the pencil leads on this one too.
Oh, cool.
Where are the pencil leads?
Pencil leads look really cool. I crushed up one as like a conductive glue when I didn't have conductive glue, and it actually worked pretty well.
There's the pencil leads.
That's so cool.
Go to...
Yeah, that tilt makes a big difference.
Right, isn't that fun? It had a conductive thing, get on it.
Whoa.
Estimation plus charging. So do a do like a 8K acquisition there, and you can do a lot lower dwell time.
16.
Yeah. And we could have done 16K too. It's just I just
Sure.
said 8
Didn't
for,
want to wait for the
yeah.
scan. Wow.
Yeah, so Spirit, the stage controller that sticks out really far here, that has like a really old, kind of terrible motor drive attachment on it. That we're just gonna rip that off and just like get it back to the stock stage knob, and then eventually put.
Yeah, I'll build something.
Yeah, you can zoom in on the LED now.
Ooh. Oh my. That's great. That's just like charging, right?
Probably.
Kind of. Well, there's kind of. Whoops.
Yeah, I mean, the whole thing is kind of covered in stuff.
Okay, because it looks like a little like fuzzy here, like a little blurry.
Yeah.
That's
I mean, I
weird.
focused on one of them.
Oh, true. Let's see. Yeah, it's got like kind of like a noise over it or something.
It is possible that one of our that we've something has started being noisy too.
Very fair.
It could be collector. It could be because we are at 5, not at 4.9.
That's true. I would expect it to be way worse if that mode had come back up though.
There's all yeah.
It still looks great.
You would have had less of that too, I think, if you were at 16 instead of 8. Because you're looking at like individual pixels.
Yeah, that's very fair. Interesting.
I do see what you're saying though, yeah.
Yeah, there's something up, but it's
Yeah.
not. Yeah, that's a very nice image. That's nicer than any image I've gotten off the scope. That's a little weird still, but that's awesome. I'm wondering if we're seeing anything weird in the live scan now. It's probably not.
Yeah, look at that. No, I could see it in the live scan.
Oh, you could?
Yeah, it's flickering some interesting ways.
Yeah.
Something's up. Yeah, I see the warbly there.
Maybe we hit the dust.
We're at 48 millimeter working distance, so that could be a magnetic field actually.
Oh.
Because when you're at, it's so sensitive when you're at super, super long working distances.
I guess that makes sense. The beam is traveling for longer.
Wow. Isolation's working really well actually. That is, okay. that is good.
Well, sick. Oh, yes. That is... So I basically just mixed it. I took some pencil. This is before I had like carbon glue. I just took a piece of graphite and I crushed it in ethanol and turned it into a paste. And then I stuck a seed to it that was... And then I coated that in silver and it imaged just fine. But you could definitely see all the broken fragments of pencil lead when you zoomed into that part, which looked really cool. I'm not recommending it, I don't know, but I did it.
You want to look at another sample tomorrow, or?
Yeah, I think so. I think this is a great stream for tonight. I also think the sun's about to come up and I should sleep at some point. So.
This sounds like a great plan.
Awesome. This is really great. Cool. Well, I'm going to go get like 3 hours of sleep.
Big monitor.
Yes.
Yes.
Honestly. I have to order a 4K monitor next.
Hey, you can, yeah.
Sweet. Well, this has been great. Thanks for all the help tonight.
No problem. I'm happy that the microscope is quieter. I'm happy that the image isn't dominated by the water trailer shaking everything. I'm happy you figured out the collector voltage.
It's probably not the mag power amp.
It's probably not the mag power amp.
Which is great.
Because I think it's I strongly suspect collector, and that would it explains the image brightness changes really.
Well, how would we
well.
fix that? What would be our
I
troubleshooting
gotta
steps?
open the box and look at what's going on. It might be visually obvious. It might be a loose solder joint. It might be one of the relays.
Sure. Yeah, that wouldn't surprise me.
And then it looks. It did seem like we found some conditions in which stuff in the column was possibly to blame.
Yeah.
So, or I'm pretty confident that was.
So
okay, I won't say I'm pretty
tomorrow-
confident. I'm yeah.
So tomorrow, do we want to try to fix the collector thing first and then start taking it apart?
The collector seems like a bigger deal to you.
Yeah.
I think you ran into that like a lot more frequently.
Yeah, definitely.
So I think we'll probably prioritize collector.
Cool. And then we can start ripping things apart after that.
That sounds like a plan to me.
Cool. Awesome. Well, thanks everybody for watching tonight.
Yeah, thank you everybody for
hanging
joining
out.
the stream. I think we're gonna be signing off here pretty soon. Oh yeah, so Maria, it's pencil lead, and then you can so did you do it in like a glass or something?
Yeah,
or
I
what?
just crushed it up in some ethanol. with
Yeah, so it's like a little container, fill it with ethanol, stick a pencil lead in it, and just like smash the lead up, and then when the ethanol dries, it just like leaves the graphite in place, and it's like conductive, and it's a little
Works
bit
pretty
sticky.
well.
Yeah, I mean it's basically what colloidal graphite is. So. Yeah, well, that was a fun stream.
Yeah.
Had a lot of fun working on the scope. Fun fact, we're on what floor?
The 5th floor.
We're on the 5th floor.
Oh, and actually, each floor in this building is like double height, so it's more like a 10-story building.
This, I'll tell you what, this like 2,000 or 3,000 pound piece of steel you have this thing on. It's doing real. I was like jumping up and down on this floor, and like I couldn't see it in the. I mean, we were only at like what 20,000 times magnification at that point, but still
Pretty good.
pretty happy with the 2,000 pound piece of steel you got to make it sit down.
And it's on wood right now too.
Yeah, no, it probably can get even better. Well, now that you got a better digital capture system, we can like.
We can actually figure some shit out.
Yeah, we can see all the Microsoft's problems more clearly. Yeah.
Sweet. That's awesome.
Cool.
Cool.
Well,
All right.
I think with that, we're going to sign off.
Yeah, it's like 5 a.m. here, so
Until
it's
next time,
for bed.
everybody. Had so much fun.
Yeah.
Bye.
Bye. Have a good night.